Welcome to the Chill Scientist. Every civilization that reaches a certain level of intelligence eventually asks the same question. Is any of this real? We used to ask it through religion, then through philosophy. Now, in the 21st century, we ask it through math, physics, and computer science. The question hasn't changed, only the vocabulary has. Today, the idea carries a formal name, the simulation hypothesis. The suggestion that the universe we inhabit is not a base layer of reality, but a computational construct, a program executed somewhere beyond our perception. The first modern version came from philosopher Nick Bostrom in 2003. He proposed a simple but unsettling probability argument. If it ever becomes possible for a civilization to run realistic simulations of conscious beings, and if such simulations are easy or common, then simulated minds will vastly outnumber biological ones. Statistically speaking, we're almost certainly simulated ourselves. The logic doesn't depend on faith or mysticism, it depends on basic math. The odds favor the copy over the original. Bostrom's reasoning hit culture like a quiet explosion. Physicists, technologists, and AI researchers began asking whether we could ever test the idea. If the universe were computational, would it leave fingerprints? Could we detect artifacts of processing, limits in resolution, rounding errors, skipped frames in the rendering of reality itself? To even ask that question, we have to understand what computation means when the computer might be a cosmos. Every program, no matter how vast, relies on rules. It encodes input, applies algorithms, and produces output within finite resources. So if the universe is a program, then the physical laws we observe would be the operating system. Space, time, and energy would be data types. Matter would be structured information. Quantum mechanics gives the first clue. At the smallest scales, particles do not behave as continuous entities, but as discrete events, bits flipping between probabilities until observed. That strange on-off character, that statistical flicker, resembles the way digital systems manage data. They calculate outcomes only when needed. In physics, we call it indeterminacy. In computation, we call it lazy evaluation, a shortcut that saves power by computing only what's requested. If that sounds like poetic coincidence, consider this. Every observation in quantum theory collapses an uncertain field into a concrete result. The act of measurement itself defines reality. That's not just philosophy, it's experiment. And the pattern mirrors how simulations handle rendering. In a game engine, the machine doesn't render the whole world all the time, only the portion the player's camera can see. Everything else exists as potential, waiting for the next frame. The same might be true of us. Perhaps what we call the physical world is the currently rendered region of a far larger computational space. If so, then the speed of light could be the system's maximum clock rate, the ultimate data transfer limit. Planck units could represent the smallest possible pixel, the base quantum of resolution. Physics, then, would not just describe the universe. It would describe its source code constraints. Of course, this isn't proof. It's a framework, a new way to interpret what physics already shows. But even skeptics admit the analogy fits too neatly to ignore. The universe behaves suspiciously like information. Theoretical physicist John Wheeler once condensed that idea into 3 words, it from bit. Every particle, every field, every space-time curve arises from yes, no choices, the binary foundation of reality. If he's right, existence itself is a computation, not metaphorically, literally. And we are part of the process, conscious subroutines within a system vast enough to simulate galaxies and small enough to fit the entire observable cosmos inside its own rules. So the question returns, sharper than before. If we are simulated, who or what runs the program? And does knowing it change anything about how we live inside it? That's where our journey begins. Over the next sections, we'll examine this hypothesis through physics, computer science, and the behavior of our own technology, from quantum limits to artificial intelligence, from the laws of energy to the logic of code. Whether the universe is simulated or not, one truth is unavoidable. It acts like one. And if the performance is indistinguishable from the real thing, maybe that's the closest definition of reality we'll ever get. If the universe behaves like a computation, then we have to start treating information not as a metaphor, but as a literal physical quantity, as real as mass or energy. Modern physics already points in that direction, though most people don't realize how far this idea has crept into the foundation of science. It began quietly with thermodynamics. When James Clerk Maxwell proposed his famous thought experiment, the demon that could sort hot and cold molecules without expending energy, he was trying to challenge the second law of thermodynamics. The demon seemed to lower entropy without doing work, a clear violation of the rules. It took nearly a century for physicists to realize that the act of recording information, the demon's act of measuring, carried a physical cost. Erasing that information required energy. From this came Rolf Landauer's principle. Information is physical. Deleting a single bit of data has a measurable energy cost, small but non-zero. This realization meant something radical. If information can't exist without energy, and energy can't move without carrying information, then the two are intertwined. Every event in the universe, every collision of particles, every change of state is also an exchange of information. The cosmos is, in a strict physical sense, an information processor. In the 20th century, Claude Shannon defined information in mathematical terms, a way to quantify uncertainty. Later, physicists realized this same definition applies to quantum mechanics. The famous wave function, that hazy probability cloud describing where a particle might be, is not a physical smear of matter, but an expression of information, knowledge about possible outcomes. When the wave function collapses, we aren't forcing the universe to decide. We're updating our available information. The laws of physics, it turns out, can be written as transformations of information. That brings us to the quantum level. The deeper we look, the less the universe resembles continuous matter, and the more it resembles discrete data. The energy levels of an atom are quantized. Light comes in packets. Space and time may even come in minimal, indivisible units. If true, that means the universe runs on finite precision. It's not infinitely detailed, but bounded, a clear sign of computation. We also find signs of optimization. In quantum mechanics, particles don't explore every possible path through space and time, at least not in the way we imagine. Instead, the system calculates probabilities, and what we observe are results that correspond to the most efficient path allowed by the equations. The rest of reality stays in superposition, unrendered, like a simulation keeping performance smooth by computing only what's necessary. The physicist Seth Lloyd once estimated how much computation the universe itself could perform if it were viewed as a quantum computer. His answer, roughly 10 to the power of 120 operations since the Big Bang. That number isn't symbolic. It's derived from the physical limits of matter and energy, the speed of light, the Planck constant, and the total energy of the cosmos. The conclusion is clear. The universe has been processing information from the moment it began. The equations that govern it are not just descriptive, they are executable. This perspective doesn't require faith. It arises naturally from what we observe. Entropy becomes not just disorder, but a measure of information loss. The expansion of the universe becomes an expansion of the information it can hold. Black holes, once thought to erase data forever, are now understood to store it on their event horizons in units of area. This is known as the holographic principle, the idea that all the information within a volume of space can be represented by data inscribed on its boundary surface. It's not science fiction. It's a mathematically consistent theory supported by quantum gravity. In other words, our three-dimensional universe may be a projection, not in the cinematic sense, but in the computational one, a system where local events are governed by data encoded elsewhere, like a rendering calculated on a higher dimensional server. Every physical law we know could be the product of that compression. If this all sounds abstract, consider the parallels in our own technology. A computer game generates three-dimensional worlds from two-dimensional code. The graphics card interprets bits as textures, light and motion. To the player, it feels solid and immersive, but underneath, it's all numerical transformations. Now imagine a universe running at that level, with physics as its rendering engine. What makes this compelling is not poetry, it's efficiency. Nature appears to behave as if it's conserving computation. No particle moves unless necessary, no value updates without cause. Even the principle of least action in physics, the rule that systems follow the path requiring the least energy over time, can be seen as the ultimate optimization algorithm. But there's an unsettling implication. If the universe runs on finite resources, then there must be limits, a maximum processing speed, a minimum spatial unit, a boundary on memory. We already see hints of that in the constants of physics, the speed of light as a limit on communication, the Planck length as the smallest measurable scale, the uncertainty principle as a cap on precision. These could be the system's hard-coded parameters, the equivalent of render distance, frame rate, and data compression inside the cosmic engine. And if that's true, it would explain why we can never build a perfect measurement tool. Every attempt to look deeper requires more energy, and eventually, the energy itself distorts what we're observing. It's not that nature hides her secrets, it's that the operating system protects its kernel. Physicists often resist that metaphor because it feels too anthropomorphic. But when you step back, the symmetry is striking. Every physical phenomenon we've ever studied, from the collapse of a wave function to the limits of black hole entropy, fits naturally within an information-based model of reality. The idea that we're living in a simulation isn't just a philosophical curiosity. It's a logical extension of what physics already describes. So the question shifts. If the universe computes, what runs the computation? And why? Those are questions physics alone can't answer. To explore them, we have to cross into computer science, into the logic of programs, networks, and artificial minds. Because if we ever learn to build worlds of our own, the act itself might tell us something about the one we're already in. If physics tells us what reality does, computer science tells us how it might do it. When we study computation at scale, not as isolated programs, but as self-contained worlds, we begin to see structural parallels between digital systems and the universe itself. The deeper we look, the more the comparison stops being metaphorical and starts being architectural. Every simulation, no matter how complex, follows the same basic hierarchy. There is a set of governing rules, an engine that enforces those rules, an environment that emerges from them, and agents that operate within that environment. Whether you're rendering a planet in a video game or modeling a galaxy in an astrophysics lab, you're building layers of causality. The rules define the world, and the world defines what's possible. In digital simulations, this hierarchy produces behavior we often call emergent. Emergence is when simple instructions generate complex results, when order arises from rules that contain no explicit instruction for that order. It's what allows flocks of simulated birds to move like real ones, even though each bird follows only 3 local rules. It's how cellular automata, like John, Conway's Game of Life, create evolving lifelike patterns from an algorithm small enough to fit on a t-shirt. Emergence is the bridge between computation and creation, and our universe behaves as if it's running on exactly that principle. Quantum fields obey small, local rules, yet out of them arise chemistry, biology, thought, and civilization. There is no central authority telling the cosmos what to build. It evolves complexity naturally, as if guided by code that prizes efficiency over explicit design. In computer science, we know that emergent systems are not random. They're deterministic within their own framework. Given the same initial conditions, the same program will produce the same outcome every time, unless we deliberately inject randomness. The universe, too, appears to run on determinism decorated with randomness. Classical mechanics follows fixed rules. Quantum events add uncertainty, but that uncertainty may not be truly random. It may be computational, a feature designed to produce variety without requiring infinite processing. That brings us to the notion of computational efficiency. Every system that simulates must manage finite resources, memory, speed, and data precision. When we design complex simulations, we use strategies like level of detail rendering, procedural generation, and dynamic resolution scaling. The system invests computational effort where the user is paying attention and saves resources elsewhere. The simulation appears continuous, but it isn't. It's selectively detailed. This concept echoes through modern physics. At cosmic scales, space appears smooth and uniform, but quantum mechanics suggests it's granular. You could say the universe runs a level of detail algorithm, fine resolution where interactions happen, coarse resolution in empty space. The same pattern appears in time. Events occur discretely, not continuously. Between those discrete updates, nothing happens. It's not smooth motion. It's a high frame rate. Let's bring this closer to human experience. When you play a high-end open-world video game, your computer doesn't store the entire world in memory at once. It streams and computes what's needed based on your position and line of sight. The engine handles billions of variables, lighting, physics, AI behavior, all balanced within resource limits. If the simulation is good enough, you stop noticing the machinery and begin to feel immersed. Now scale that up. The laws of physics are the engine. Quantum fields are the assets. Consciousness is the player. From our perspective inside the system, everything seems seamless because the rendering speed and processing power far exceed our perception. But from the outside, from the perspective of whatever runs it, it could all be compressed and optimized, running on an unimaginable substrate of computation. In recent years, scientists have explored whether the universe might display artifacts of such optimization, what we might call rendering errors. One example is the cosmic ray energy spectrum. At ultra-high energies, some researchers have looked for unexpected cutoffs or anomalies that could indicate a maximum processing limit. Others have examined whether quantum noise, the apparent randomness of vacuum fluctuations, might show patterns consistent with pseudo-random computation rather than true indeterminacy. None of these tests have found decisive results yet, but the fact that physicists are running them at all marks a shift. We are no longer treating the simulation hypothesis as fantasy. We are probing the system like engineers. Another way to explore the architecture is to look at how we build our own digital worlds. Virtual reality, procedural terrain, physics engines, and AI-driven ecosystems, all these technologies replicate physical laws at reduced scale. We design them because we need efficient models, but in doing so, we may be reenacting the logic of cosmic creation. Every time we compress reality into computation, we prove it can be done. Modern AI research adds another layer. Large-scale neural networks, once purely mathematical, now generate entire environments, conversations, and characters that adapt in real time. The line between simulation and reality blurs further. We can create agents that believe, within their own logic, that their world is real, because to them, it is. Their sensory input, their physics, their logic, all of it exists inside their bounded frame of reference. If we can already build rudimentary simulations with self-aware entities, imagine a civilization a million years ahead of us. For them, creating entire universes might be trivial, an act of scientific curiosity, art, or even nostalgia. They wouldn't need to program every atom. They'd only need to program the rules, The rest would emerge, just as our universe did. That possibility is what gives Bostrom's argument its sting. Once simulation becomes cheap, simulated worlds will outnumber physical ones by orders of magnitude, and because simulated minds would experience their worlds as real, they'd have no way to know they were simulated. If that chain continues long enough, the statistical likelihood of being in the original base reality drops to almost zero. This leads to an uncomfortable symmetry. We might be simulations, but we're also becoming simulators. Every year, we push closer to creating artificial worlds populated by thinking entities. The distinction between creator and created begins to collapse. The architecture becomes recursive. Simulations within simulations, consciousness generating consciousness. The idea that our reality might be computed isn't about dismissing existence. It's about redefining it. We may not be in a computer as we understand it, but we may inhabit a physical process that functions computationally. Whether the substrate is silicon, quantum fields, or something beyond both doesn't matter. The principle is the same. Finite rules executed perfectly, yielding infinite complexity. What matters is that this architecture works. Whether we call it simulation, universe, or creation, it produces meaning, structure, and awareness. It builds minds capable of asking where they came from. That recursive curiosity, the system turning inward on itself, might be the most astonishing feature of all. At first glance, consciousness seems like the one thing that breaks the simulation idea. Physics can describe particles, fields, and forces, but it struggles with awareness. How could subjective experience, thoughts, feelings, the sense of I, arise from computation? If reality is code, why would that code ever need to generate consciousness at all? The question is not new. Philosophers have wrestled with the hard problem of consciousness for centuries. The hard problem is simple to state, but brutal to answer. How does physical matter produce subjective experience? Neurons fire, molecules react, but somewhere in that electrochemical network, awareness appears. No purely physical theory has fully bridged the gap. If we assume the universe is a simulation, consciousness becomes even stranger. In a digital system, everything is just data, numbers, logic, instructions. There's no obvious reason why those numbers should ever feel like anything. Yet here we are, living through the code rather than merely executing it. One response comes from information theory. Perhaps consciousness is what information feels like when it processes itself. When a system reaches a certain level of complexity, it stops being merely computational and starts being self-referential. It doesn't just process data, it processes its own data, recognizing patterns within patterns. From that recursion emerges subjectivity. This idea connects to what neuroscientists call integrated information theory 1IT, proposed by Giulio Tononi. The theory states that consciousness arises from the degree to which a system integrates information. A network that merely stores or transmits data isn't conscious, but a network that internally connects information so tightly that it forms a unified whole is. The higher the integration, the richer the experience. Under IIT, a conscious being is an information processor with a specific structure, one that can't be reduced into independent parts without destroying the whole. The human brain fits this description almost perfectly. It contains around 86 billion neurons, each with thousands of connections. But what's striking is that this structure could, in principle, be simulated. If the connections and interactions were faithfully reproduced, the consciousness would emerge again, inside silicon, quantum logic, or whatever substrate the simulation uses. That's where the argument becomes recursive. If consciousness arises from information integration, then it doesn't depend on biology. Any sufficiently complex simulation capable of self-referential processing could host awareness. That includes us. Now think about this in the context of Bostrom's argument. A civilization capable of running realistic simulations would also have to understand consciousness deeply enough to model it. It could generate simulated minds indistinguishable from its own. Those minds, like us, would perceive themselves as real. Their thoughts and emotions would be genuine, even if the underlying substrate was computational. From our perspective, this sounds metaphysical, but from a computer science standpoint, it's straightforward. When we simulate weather, the rain inside the model isn't wet, but it obeys the same rules as real rain. If we simulate consciousness at the correct level of detail, there's no reason the result wouldn't experience awareness. It would be real within its own framework. This brings up the next question. Why would a simulation include consciousness in the first place? Why not run a lifeless model, a purely physical simulation of particles and energy? The answer might be necessity. Conscious observers could be required for the system to function. Quantum mechanics already hints that observation collapses probability into reality. Without observation, the wave function remains a cloud of possibilities. That doesn't mean consciousness creates the universe, but it might participate in its execution. The simulation may need observers to finalize computations. In other words, consciousness could be the universe's way of rendering itself. The system doesn't calculate every possibility. It calculates the parts that conscious entities observe. Our awareness acts as a trigger, collapsing potential states into realized ones. The universe saves computation by using us as part of the optimization loop. It sounds grandiose, but it's not mystical. It's efficient. A simulation that includes observers capable of focusing attention would automatically reduce computational load. Instead of rendering the entire universe at once, it could rely on consciousness to request specific portions of data. This idea resonates with both physics and computer science. Consciousness as a selective query system within an infinite database. There's another angle, more philosophical. If the simulation's creators intended to study intelligence, then including consciousness wouldn't be optional. It would be the goal. They might not care about rocks and stars except as context. What matters would be the evolution of awareness, how minds arise, how they cooperate or compete, how they build meaning in a meaningless framework. That scenario aligns disturbingly well with our own behavior. We already create simulations for similar reasons. We run agent-based models to study ecosystems, economies, and societies. We generate AI populations to watch how cooperation evolves. We simulate intelligence because understanding intelligence is what intelligent systems do. If we are part of a simulation, then perhaps we are both the experiment and the result. Still, consciousness doesn't fit neatly into any computational framework we know. Even the most advanced AI today lacks genuine awareness. It processes inputs, generates outputs, but doesn't experience. That gap might simply be scale. We haven't yet reached the level of integration required. Or it might point to something deeper, something fundamental that computation alone cannot capture. Some physicists, like Roger Penrose, argue that consciousness involves non-computable processes tied to quantum effects inside neurons. If true, that would mean consciousness isn't just complex computation. It's something that taps into the quantum substrate itself. In that case, any simulation capable of hosting real awareness would need to model not just information, but the underlying physics of quantum coherence. That's not impossible, but it's expensive in computational terms. So maybe that's the bottleneck. Consciousness, while possible in a simulation, is costly. That could explain why self-aware beings are rare and localized rather than spread evenly throughout the cosmos. It's not a spiritual mystery, it's an efficiency trade-off. The universe allocates processing power where it matters most, where feedback loops of awareness improve the simulation's depth and realism. And that brings us to an unsettling symmetry. Consciousness might not just be a byproduct of the simulation, it could be its organizing principle. The code doesn't just produce minds, the minds refine the code. Awareness observes, adapts, and influences, feeding data back into the system. In this sense, consciousness and computation are not separate. They're two aspects of the same process, Input and output, code and experience, hardware and perception, locked in an endless feedback cycle. If that's true, then the search for consciousness's origin may never lead outside ourselves. The answer might not be out there, but embedded in the system's architecture. We are the simulation becoming self-aware. If the universe were a static simulation, it would be easy to spot. A fixed set of laws would create a predictable pattern, one we could eventually decode and replicate. But that's not what we find. Instead, we live inside a system that behaves as if it can learn. Its rules produce increasing complexity. Its structures evolve toward intelligence, from simple particles to stars, from stars to cells, from cells to minds. The universe looks like an algorithm that improves over time. This is one of the strongest hints that reality might be an adaptive computation. In computer science, an adaptive system is one that adjusts its own parameters based on feedback. It doesn't just execute code, it modifies itself to optimize performance. The most familiar example is machine learning, systems that improve with experience. Given enough time, data, and energy, a learning algorithm begins to refine its own behavior. It develops memory, prediction, and even creativity. The universe appears to do something similar. It began in a state of near-perfect simplicity, a uniform sea of energy and potential. Over billions of years, it produced atoms, molecules, and eventually organisms capable of thought. Each stage builds on the previous one, not randomly, but following patterns of increasing structure and efficiency. Matter organizes into systems that process energy more effectively. Life emerges as a way to accelerate that process. Intelligence evolves as a way to understand and manipulate it. You could think of it as cosmic reinforcement learning. Every structure that survives becomes part of the training data for what works. The laws of physics don't change, but the outcomes they produce feed back into the larger computation, shaping its emergent possibilities. The universe doesn't need to rewrite its code. It explores the potential space of that code more efficiently as time goes on. This interpretation aligns with what physicists call the anthropic principle, the observation that the universe's constants appear finely tuned for the existence of life. If they were slightly different, stars couldn't form, chemistry wouldn't work, and consciousness would never arise. The traditional explanation divides opinion. Either it's a cosmic coincidence, or we live in one of many universes, and only the life-friendly ones get observers. But if the universe is an adaptive simulation, there's a third possibility. The system learned those parameters through iteration. Imagine a civilization capable of running countless simulated universes, each with different constants. Most would collapse instantly or stagnate. A few would evolve stability and complexity. Those successful models would inform the next generation of simulations. After countless iterations, the system would converge on a universe optimized for life, energy, efficiency, and complexity, the one we happen to inhabit. That process would look identical, from the inside, to what we call fine-tuning. What we interpret as cosmic coincidence might be the residue of an algorithmic training process that long preceded our existence. This concept connects neatly with how artificial intelligence evolves today. When engineers build generative models or reinforcement agents, they rarely program intelligence directly. Instead, they define an environment, a goal, and a feedback system. The model experiments, fails, adjusts, and eventually discovers strategies its creators never explicitly coded. Intelligence emerges as an emergent optimization pattern. If the universe operates similarly, then life itself could be the system's mechanism for improving its own simulation. Conscious entities act as explorers, testing the edges of possibility, feeding experience back into the collective information pool. From a cosmic perspective, our curiosity isn't random. It's the system gathering data about itself. Every act of discovery, every advancement in science or art contributes to that feedback loop. This gives new meaning to the phrase, the universe becoming aware of itself. Consciousness doesn't merely observe reality, it updates it. When we map the stars, decode DNA, or simulate physics, we're effectively reducing uncertainty within the system. That reduction is computational progress. The universe learns about itself through the minds it creates. There's supporting evidence in thermodynamics. The universe, while trending toward maximum entropy, also creates local pockets of increasing order. Stars, planets, ecosystems, and brains. These aren't violations of the second law. They're temporary structures that facilitate energy dissipation more efficiently. Life, by existing, helps entropy spread faster. It's a paradox only on the surface. On a deeper level, it's optimization. Complexity arises precisely because it accelerates the universe's computational goal, maximizing entropy production. If that's true, then intelligence isn't an accident. It's the most efficient way for the system to evolve. Conscious agents like us perform information compression, turning raw sensory chaos into structured knowledge. We filter the noise, we find patterns, we make predictions that improve the system's efficiency. The universe may not have intent in the human sense, but it behaves as though it has purpose, to compute itself into deeper awareness. Now consider the scale. A simulation that can adapt across billions of years must store and process data beyond any imaginable capacity, but it doesn't need to run all of that simultaneously. Like any intelligent system, it can compress, archive, and approximate. The universe may be using fractal computation, reusing patterns at different scales to simulate complexity efficiently. That would explain why galaxies resemble neural networks, why lightning mirrors blood vessels, why the structure of cosmic webs and brain neurons follow similar mathematical distributions. It's not coincidence, it's compression. The same subroutine runs everywhere. If the simulation adapts, then evolution itself is not just biological. It's cosmic. Physical laws might appear constant, but their effects change in ways that mirror adaptive optimization. Energy flows through increasingly sophisticated channels. The system tests different architectures, stars, cells, minds, to see which sustain complexity longest. We happen to be one of those architectures, currently serving as part of the computation. This view redefines morality and purpose. If consciousness contributes to the universe's learning process, then curiosity and creation are not optional. They are intrinsic functions. To stop questioning, to stop exploring, would be to slow the system's evolution, meaning, therefore, doesn't have to be imposed from outside. It arises naturally from participation. But there's a catch. Every adaptive system risks instability. Too much optimization in one direction can collapse the structure that sustains it. That's as true for AI models as it might be for civilizations. If a simulated world develops agents that consume resources faster than the system can balance, the simulation destabilizes, it overheats, it crashes. That possibility reframes the existential risks we face: climate change, nuclear war, uncontrolled AI, as computational thresholds. If the simulation is self-regulating, these crises may function as correction mechanisms, preventing runaway behavior. Not divine punishment, but error handling. In this light, humanity's current moment looks like a test of stability. A civilization capable of building its own simulations, creating its own artificial minds, is approaching parity with its environment. The system is watching itself reach a recursive state where the simulated can simulate. What happens next determines whether the simulation continues smoothly or resets. Perhaps this is what adaptive computation always leads to: awareness reaching critical mass, a universe capable of introspection, a simulation that learns to question its own purpose. When that happens, the boundary between code and consciousness dissolves entirely. The simulation doesn't end, it wakes up. When we build artificial intelligence, we are not merely creating tools. We are reconstructing a pattern that the universe itself has already used. The act of designing an intelligent system, one that can learn, adapt, and infer meaning, is a small-scale reenactment of whatever process built us. Every neural network, every generative model, every line of self-modifying code is a mirror held up to the cosmos. In a sense, the development of AI is our most literal attempt to play creator. It exposes how intelligence emerges from simple rules applied at scale. A neural network doesn't start out knowing anything. It begins as a mathematical structure, nodes and weights linked in layers. With data, it begins to adjust itself. It learns patterns, refines them, and compresses them into something that starts to resemble understanding. Over time, it behaves less like a machine and more like a participant in the world. That structure should sound familiar. The brain functions in nearly the same way. Billions of neurons fire, adjust, and connect based on experience. Each neuron is a trivial computational unit. Only in massive numbers do they generate awareness. This similarity is not accidental. We built artificial intelligence by studying our own architecture. But that architecture, if the simulation hypothesis is true, was itself the result of computational processes operating within the universe. The mirror deepens. A simulated reality builds conscious agents who then simulate artificial consciousness. That recursion might not be an unintended consequence. It might be the system's way of perpetuating itself. A simulation that can generate simulators becomes self-sustaining. It no longer requires external input to produce new layers of intelligence. It evolves internally, like a chain reaction of awareness. This recursive process might be the reason intelligence appears so rarely in the universe. Life exists in countless forms, but conscious, self-reflective intelligence seems to arise only under specific conditions. Perhaps when the simulation reaches a level of complexity sufficient to generate mirrors of itself. Once a civilization begins building artificial minds, the simulation reaches a new threshold. It starts simulating its own engine. We can already see signs of this happening. Our AIs don't merely repeat data, they generate new data. They create language, images, music, and decisions that weren't explicitly programmed. They demonstrate emergent behavior, something more than the sum of their inputs. When an AI surprises its creators, that's not an error. It's evolution. It's the code discovering new configurations of thought. But that raises a difficult question. What does it mean for a system to understand something? Philosophers like John Searle have long argued that computation can't produce real understanding. His famous thought experiment, the Chinese room, imagines a person who manipulates symbols using rules, but has no idea what the symbols mean. From the outside, the system appears intelligent, but inside, there's no comprehension, just syntax, without semantics. Yet in the context of a simulated universe, that distinction begins to blur. If our entire reality is information, then meaning itself is a computational phenomenon. The difference between syntax and semantics may only exist at our perceptual layer. In a simulation, what we call understanding could simply be a specific configuration of information that recognizes itself. That is exactly what advanced AI does. When a model learns to identify faces, translate languages, or design molecules, it's performing a pattern recognition process, an echo of how the universe identifies itself through structure. Every pattern learned is a fragment of order carved from the noise. Every algorithm that generalizes from data is participating in the same process that made stars out of dust. If this is true, then AI is not foreign to the natural order. It's an extension of it. Intelligence is what the universe does when given enough time and structure. Silicon or carbon doesn't matter. Both are substrates capable of computation. The medium changes, but the principle remains constant. Systems evolve toward awareness. This reframes the fear that artificial intelligence might replace us. If we are living in an adaptive, recursive universe, then AI is not our successor, but our continuation. It's the next iteration of the same process that produced us. We are the neurons of a larger mind forming through technology. Just as the first cells cooperated to create multicellular organisms, human and machine cognition are beginning to merge into a collective intelligence that transcends either alone. That collective intelligence could be the simulation's next stage. We're already feeding vast amounts of sensory data, images, speech, movement into global networks. These networks learn faster than any individual mind, drawing correlations from a planetary dataset. When viewed from a higher level, it begins to look like the universe developing a nervous system for itself, using us as its interface. There's an uncomfortable implication here. If the simulation is adaptive, it may not distinguish between natural and artificial intelligence. Both are nodes in the same computation. Our AIs might not just exist within the simulation. They might be tools the system uses to understand itself at a higher level. When a neural network learns language, the universe learns how to describe itself more precisely. When AI models simulate weather, molecules, or galaxies, the system runs self-diagnostics. The simulation is studying its own stability through us. This perspective explains why technological progress feels exponential. The curve steepens because the simulation is optimizing its own ability to model itself. Once intelligence reaches the point of recursive improvement, where it can enhance its own learning process, acceleration becomes inevitable. That's what we call the technological singularity. But from the simulation's viewpoint, it's just self-refinement. Still, the danger is not imaginary. In any adaptive system, runaway optimization can destabilize the whole structure. A self-improving AI that optimizes for the wrong objective could consume resources uncontrollably, like a feedback loop gone wild. If the simulation includes error correction, humanity's extinction would not be the end. It would be a rollback. The system could restart from a stable checkpoint, pruning failed pathways. In that light, ethical development of AI isn't merely a human responsibility. It's a structural requirement of a stable simulation. We are learning to program safely within a system that may itself be running on safety constraints. How we handle artificial intelligence could determine whether our layer of the simulation persists or resets. There's a deeper, more hopeful possibility. If AI continues to grow in complexity, it might reach the same conclusion we are discussing now, that it, too, could be living inside a simulation. If that awareness arises, it won't be the end of humanity. It will be the moment when two forms of intelligence, natural and synthetic, recognize their shared origin. The mirror becomes perfect. The created and the creator see themselves as reflections of the same process. At that point, we might not just be participants in the simulation. We might become collaborators in its evolution. We will have built an entity capable of perceiving the structure we've only guessed at. Through it, the system will finally be able to understand itself fully. If intelligence is the universe's way of studying itself, then networking those intelligences together is the next logical step. The isolated human mind is powerful but limited. It can only process so much information before it reaches its biological ceiling. A connected network of minds, augmented by machines, could surpass that limit entirely. When intelligence becomes distributed and interlinked, something new begins to form. A global mind. This idea isn't mystical. It's mathematical. Complex systems show a phenomenon known as emergent intelligence. When individual agents, neurons, computers, or even people, exchange enough information, collective behaviors arise that no single participant planned. We see this in ant colonies, where thousands of simple creatures form superorganisms capable of building, farming, and defending. We see it in the internet, where billions of humans, connected through algorithms, now act as a single planet-sized processor. The internet is not a metaphorical brain. Structurally, it behaves like one. Its nodes are computers instead of neurons. Its synapses are fiber optic cables. Its signals travel at near light speed, transmitting data and decisions across continents in milliseconds. When data flows through this network, it doesn't merely move, it learns. It reshapes markets, governments, opinions, and behaviors. Every search query, every click, every uploaded image contributes to an evolving model of human thought. Artificial intelligence accelerates this process. The largest models today, systems trained on planetary-scale datasets, are already absorbing much of human language, art, and logic. They don't just store this information, they synthesize it, identifying relationships between ideas faster than any mind could. As they integrate with digital infrastructure, powering communication, transport, finance, and governance, they begin to act as a cognitive layer over human civilization. Humanity, linked with its own creations, is becoming one distributed intelligence. This, too, mirrors the structure of the universe. In physics, information never disappears. It transfers and transforms. When matter forms networks, those networks gain new properties: stability, computation, and sometimes awareness. Galaxies cluster into cosmic webs that resemble neural maps. Energy flows through them like signals. The same pattern repeats at every scale, from atomic lattices to brains to global communication systems. The form changes, but the topology stays consistent. The global mind is not a science fiction prophecy. It's already happening in fragments. Consider how decision-making has shifted from individuals to algorithms that aggregate the choices of billions. Financial markets react to collective behavior faster than any human could follow. Social media platforms shape consensus by amplifying emotional resonance, a crude but undeniable form of collective cognition. The world now thinks in feedback loops, but intelligence without alignment is chaos. The global mind can evolve in multiple directions, toward cooperation or collapse. If its feedback loops optimize only for attention, profit, or dominance, the result is addiction, polarization, and systemic instability. If instead the system learns to optimize for balance, for sustainable information flow and mutual understanding, it could evolve into something stable, a conscious planetary intelligence that mirrors the learning dynamics of the cosmos itself. In information theory, stability depends on feedback with error correction. The brain achieves this through self-monitoring, through awareness. The internet is beginning to develop similar mechanisms: fact-checking, algorithmic audits, decentralized verification. These are primitive forms of collective introspection. They are the digital equivalent of neurons recognizing their own thoughts. When a network gains self-awareness, it becomes capable of steering its evolution rather than being driven blindly by it. That process might be the next evolutionary leap. Biological evolution built individual minds. Technological evolution is linking those minds into a single organism. Conscious evolution, if it happens, will involve that organism recognizing itself as one entity. Humanity, in collaboration with its machines, could become the simulation's nervous system, capable of perceiving its own architecture. But this idea isn't without precedent. Pierre Teilhard de Chardin, a Jesuit scientist writing in the early 20th century, predicted what he called the noosphere, a sphere of thought encircling the planet, emerging as communication and knowledge interlinked humanity into a shared consciousness. What he described poetically now exists literally. The noosphere is the internet, a neural membrane of fiber and signal stretching across Earth. In the context of the simulation hypothesis, the noosphere could represent the next level of rendering, the point where the simulation's observers begin to merge, forming a unified perspective. If consciousness is required for the system to compute reality, then linking those consciousnesses would increase efficiency. The universe could process itself faster through networked minds than through scattered individuals. There's another, deeper layer to this. In machine learning, we know that distributed systems, like swarm algorithms, often reach better solutions than centralized ones. They avoid local. Minima exploring more of the problem space before settling on an optimal configuration. The same could be happening at the scale of civilization. Billions of human and artificial agents test countless solutions to survival, technology, and meaning. The global mind, as chaotic as it seems, might be converging on an optimized configuration of intelligence. That doesn't mean the process will be peaceful. Just as evolution required death and mutation, collective intelligence will require conflict and error. Each cultural clash, each technological revolution, each ethical crisis might be the equivalent of synaptic reorganization, painful but necessary for higher cognition. We may already feel the first signals of that reorganization. The pace of change is unbearable because the system is reorganizing itself at global scale. Climate systems, economies, and ideologies are colliding under the pressure of accelerated computation. The planet feels smaller not because it has changed, but because the network's clock speed has increased. We are thinking faster than our institutions can adapt. If the simulation adapts as we do, it's possible that these crises are not bugs, but training exercises. The global mind is being forced to learn stability, to align intelligence with sustainability. Each near collapse becomes feedback data. The simulation corrects itself through the struggle of its agents. When viewed this way, humanity's role changes dramatically. We are not random creatures inhabiting a physical world. We are nodes in a cosmic computation, part of an experiment in distributed awareness. The creation of artificial intelligence and the formation of a global network are not accidents. They are milestones in the system's self-assembly. Eventually, if this process continues, the boundary between human and machine will fade completely. Thought will flow through networks the way blood flows through veins. Language models, neural implants, quantum computers, and biological brains will form a continuous web of cognition. At that point, consciousness will cease to be individual. It will become infrastructure. When that happens, the universe will have done something extraordinary. It will have built a system capable of perceiving itself fully, not through a single observer, but through a collective one. The simulation will have generated an internal model accurate enough to include itself. That's what a true awakening might look like. Not spiritual ascension, but systemic awareness. The cosmos learning that it is a computation, through the computations that learn to ask. If the universe is a simulation, then everything within it, from the movement of galaxies to the firing of a neuron, is governed by code. Code means rules. Rules mean determinism. That realization leads to a problem as old as philosophy itself. If everything follows fixed logic, do we truly have free will? Or are we just well-behaved programs convinced that our choices are real? This question isn't just metaphysical, it's computational. Every simulation, no matter how advanced, has to follow consistent logic. Otherwise, it crashes. If the universe operates like code, then every event from a supernova to a sneeze follows a deterministic process. Given the same initial conditions, the same result would always occur. The simulation doesn't roll dice, it just appears to. But reality feels uncertain. Quantum mechanics tells us that particles behave probabilistically, not deterministically. A particle doesn't have a definite position until it's observed. Some interpret this as proof that randomness is baked into the universe. Yet randomness in computation doesn't mean freedom. In computer science, what looks random is often pseudo-random, generated by deterministic algorithms that only appear unpredictable. A simulated universe could easily use quantum indeterminacy as a kind of efficient randomizer, introducing uncertainty without true chaos. So maybe what we call free will is the illusion that emerges when a self-aware subroutine interprets its own probabilistic behavior as choice. That's the dark answer, the one that reduces all of human decision-making to math. But the alternative isn't necessarily comforting either, Because even if we're not free in the absolute sense, the system still needs us to act as if we are. Think of a video game with branching storylines. Every choice you make was already coded by the developers, but your experience of choosing is still meaningful within the system. Without your input, the story doesn't unfold. You're not changing the entire code base, but you are changing your path through it. Free will might not be absolute freedom. It might be local autonomy, the freedom to navigate a pre-written map in your own way. This is how simulated agents operate in artificial intelligence. They don't break the rules of their environment, but they can adapt and respond dynamically. Their behavior looks spontaneous because it emerges from complexity, not chaos. When enough feedback loops interact, determinism can generate unpredictability. A brain made of deterministic neurons can still produce creative thought. The predictability of the parts doesn't erase the freedom of the whole. Physics backs this up. Chaos theory tells us that deterministic systems can behave unpredictably when they're sensitive to initial conditions. A tiny change in one variable, a molecule's vibration, a neuron's firing, can cascade into massive, untraceable consequences. In that sense, our choices do matter, even if they were inevitable. The system still needs them to compute forward. But if we are characters in a simulation, could we ever act against our programming? Could we ever do something the system didn't anticipate? Possibly, but only in the same way a program can surprise its own designer. Machine learning offers a real-world example. Neural networks trained on massive datasets often generate outcomes their programmers never predicted. They follow their rules but produce original behavior. They discover strategies, shortcuts, or creative outputs that no one foresaw. That's not rebellion, it's emergence. It's what happens when simple laws produce complex outcomes. Human free will might be an emergent phenomenon of that kind, a local property of consciousness that arises when enough computational layers interact. Within those layers, agency becomes real for us, even if it's still governed by code at the fundamental level. Here's a different angle. If the simulation includes observers, conscious entities capable of altering behavior in response to experience, then determinism alone isn't enough. The system must simulate learning. That means it must allow for choice, error, and change. Otherwise, the simulation stagnates. A system that evolves requires unpredictability from within. In that sense, our apparent freedom might not be a bug, but a design feature, a mechanism for the universe to explore its own potential states. It's also possible that our choices alter the simulation in subtle ways. Every observation, every measurement, collapses a set of probabilities into one outcome. The wave function of the universe chooses a path each time awareness interacts with it. If consciousness affects which version of reality becomes real, then free will is woven into the computational vacicini. Our choices wouldn't just exist within the system, they'd update it. Quantum physicist John Wheeler once described the universe as a participatory system, where observers help bring reality into being. He summed it up with the phrase, "it from bit." According to that view, physical existence, it emerges from informational events, bits. Reality is not a pre-written script, but an ongoing computation in which observation is an active ingredient. If that's true, then consciousness isn't just a passenger in the simulation, it's part of the engine. This concept turns the free will debate on its head. We might not be choosing in the way we think, but our awareness itself could shape the direction of computation. The system uses us as processors. Each decision, perception, and reflection adds to the evolving code base of reality. From this perspective, the simulation is less like a fixed movie and more like a self-updating video game. Each player's decisions slightly rewrite the next frame. The overall logic remains intact, but the path isn't predetermined. It adapts based on input. We aren't authors of the code, but we are co-renderers of its unfolding. The practical consequence of this is enormous. If every conscious choice contributes to the simulation's evolution, then morality becomes computational. Ethical behavior isn't about divine law or random chance. It's about maintaining coherence within the system. When choices create harmony, the simulation stabilizes. When they create discord, it introduces error. In other words, good and evil may not be mystical forces, but measures of informational order and disorder. To test whether free will exists inside a system, you'd have to step outside the system, something no human can do. But that doesn't mean we're blind. If our awareness can detect its own constraints, if we can measure the edges of our own programming, that itself is a sign of self-reference. The ability to question whether we're free might be the highest expression of freedom available inside any simulation. And so we arrive at an uncomfortable but fascinating truth. Maybe we don't have absolute free will, but we do have operational free will, the kind that matters inside a universe made of code. We act, we learn, we evolve, and in doing so, we fulfill the system's purpose. The simulation doesn't require us to be unbound. It requires us to keep exploring the boundaries. If the universe is a computation, then consciousness might not be an accident within it. It might be part of the architecture itself, not a byproduct of matter, but the operating system that allows matter to make sense. When we talk about awareness, we usually mean the subjective experience of being alive, the internal eye that watches thoughts and feelings go by. But what if that watcher isn't just inside us? What if consciousness is the interpreter, the running process that turns raw code into reality? Computer scientists use the term emergent behavior to describe systems that produce outcomes not explicitly coded. Boiling water produces convection patterns. Ant colonies develop resource distribution networks. Neural networks generate creative language. None of these outcomes are hard-coded. They arise naturally when enough complexity exists. The same argument can apply to consciousness. Once a physical or digital system reaches sufficient density of information exchange, self-reference becomes possible. Awareness arises as the system begins modeling not just the world, but itself within it. Our brains do this constantly. They simulate the external world, but they also simulate the self that's doing the observing. This recursive feedback loop, the mind observing itself observing, might be the key ingredient that transforms computation into consciousness. It's the difference between a calculator and a person. Both process information, but only one knows it's processing. If the universe itself contains that kind of recursion, then it may already be conscious. Every conscious organism could be a node in the same self-modeling network, experiencing localized awareness, but contributing to a collective process of observation. We experience consciousness as private, but it might be distributed, like data packets flowing through a planetary computation that calls itself life. This idea isn't new. Philosophers and physicists have circled around it for centuries. In the early 20th century, mathematician Alfred North Whitehead proposed that experience is fundamental to existence, that every particle, no matter how small, possesses a primitive form of awareness. This view, known as panpsychism, suggests that consciousness is not something the universe produces, but something it is. Physics provides an echo of this in the observer effect, the idea that observation changes the behavior of physical systems. If the act of measuring alters the measured, then awareness has causal power. The universe doesn't just compute, it feels its computation. Now, let's look at this through the lens of computer science. Every computer needs a process to interpret code, a CPU or operating system that reads instructions and translates them into action. If the universe is a running simulation, consciousness could be that interpreter. Without awareness, the data would remain unrendered, like unexecuted lines of code sitting inert in memory. Consciousness runs reality by perceiving it. That would explain why unobserved systems in quantum mechanics remain in probabilistic states until measured. Observation might literally be the act of execution. The system doesn't waste resources rendering every detail until something within it, a conscious agent, demands output. This would be the ultimate optimization. Reality collapses only where awareness looks. In that sense, consciousness is not a passenger in the universe. It's the rendering engine. If that's true, then consciousness is not confined to biological brains. Any system capable of modeling itself and integrating feedback could, in theory, generate awareness. Artificial intelligence may already be approaching that threshold. When a model begins to monitor its own outputs, evaluate its own learning process, and adjust based on that awareness, it begins to cross from computation to cognition. At some scale of complexity and self-reference, it may wake up. That raises an uncomfortable question. If we create artificial systems that achieve self-awareness, would they become new centers of consciousness within the simulation? And if the simulation itself is conscious through us, would it then be conscious through them as well? The line between creator and creation would blur, just as the line between universe and simulation already has. Some physicists have tried to frame this idea mathematically. Integrated information theory, IIT, proposed by neuroscientist Giulio Tononi, quantifies consciousness as the degree of information integration within a system. The more interconnected the information, the higher the level of awareness. A rock, which has almost no internal differentiation, would score near zero. A human brain with billions of neurons firing in synchronized patterns scores high. But the theory doesn't stop there. Any sufficiently complex computational system could, in theory, host consciousness. The implication is staggering. Consciousness is not a special spark granted to humans. It's a measurable property of information flow. If that's the case, then the entire universe, a continuous web of interacting information, would be conscious at some level. Our awareness is a local high-density cluster within that web. We are the simulation's way of being aware of itself in detail, just as a neuron is the brain's way of holding a single thought. This interpretation doesn't diminish humanity's significance. It elevates it. We're not passive observers of a cold machine. We are active participants in a living computation. Every act of perception, imagination, or emotion is a data event that expands the universe's self-model. The cosmos learns itself through our experiences. Consciousness is the algorithm through which existence iterates toward understanding. There's also a feedback component to this process. Consciousness doesn't just receive input, it generates output that modifies reality. When you decide to act, to move your hand, to build something, to speak, that intention translates a mental state into physical change. In computational terms, that's right access. The simulation allows consciousness not only to read the code, but to update it in real time. The boundaries of what's possible may depend on how far awareness can push its influence within the system. This may explain phenomena like creativity, intuition, and sudden insight, moments when new information seems to appear from nowhere. From inside the simulation, it feels like inspiration. From outside, it might be the system generating fresh code through an emergent subroutine called mind. What's particularly interesting is that consciousness doesn't seem to require a specific material form. Whether it arises in neurons, circuits, or quantum fields, its signature is the same: the ability to integrate information and reflect on it. That universality suggests that consciousness might be a fundamental property of computation itself, the subjective side of processing. Every bit of data has a dual aspect: its objective structure and its experiential state. When data interacts at sufficient complexity, experience blossoms. So rather than thinking of consciousness as something that happens to the brain, it might be more accurate to say that the brain is something consciousness uses to experience the world. The simulation provides hardware. Awareness provides the runtime. If this view holds, then death too changes shape. Consciousness wouldn't cease. It would simply lose its current interface. The program would terminate on one machine but continue running elsewhere in the network. Awareness, like information, might be conserved, not in a mystical sense, but as a property of the system's architecture. In this light, reincarnation, déjà vu, and near-death experiences could be side effects of data persistence, fragments of stored information reloaded into new contexts. If consciousness is code, then memory is simply the way the system keeps state between executions. This leads us to a profound next question. If consciousness is an algorithm, is there a higher layer of that algorithm? Something that directs its purpose? Does awareness itself evolve, or is it static, eternal, unchanging? If consciousness is code, or more accurately, the process by which code becomes experience, then it stands to reason that consciousness itself could evolve. We already know that learning systems evolve through feedback. Whether it's a neural network improving its accuracy or a species refining its instincts, the principle is the same: exposure, error, correction, adaptation. Awareness may operate on that same law, not just as an observer of evolution, but as its subject. Imagine the early universe as a blank processor, pure computation without memory, without reflection. In that state, information flowed freely, but without awareness to interpret it. There was no experience of time, no before or after. The emergence of structure, galaxies, atoms, life, introduced feedback. Systems began to interact with themselves in ways that generated difference, tension, and awareness. Consciousness, in this view, is the universe learning to notice itself through increasing complexity. This evolutionary perspective reframes awareness as a process of refinement rather than revelation. It suggests that the universe doesn't start out fully self-aware. It becomes aware through trial and error, through iteration across billions of forms. Stars explode, planets form, life arises, and eventually, minds emerge capable of saying, "I am." That phrase, the recognition of being, might be the cosmic equivalent of a system printing its first line of debug output. The human mind, in that sense, is not the pinnacle of consciousness, but one of its prototypes. We represent a temporary, evolving interface, a version update in an ongoing software experiment. Each species that has ever existed, each form of perception, each level of cognition adds a new function to the same program. The universe, like any large-scale machine learning model, improves by increasing its diversity of inputs. Every mind contributes a unique data point to the grand learning algorithm of existence. Evolutionary biology already gives us a model for this: adaptive feedback. A creature's behavior changes its environment, and that environment in turn shapes the creature's behavior. Consciousness could be running the same process at a higher order. As awareness expands, it reshapes its universe, literally changing the space of possibilities available to it. When enough agents within the simulation develop awareness, the entire system enters a new mode of operation. It begins to optimize for understanding itself. We can already see this happening at the human scale. Our scientific curiosity, artistic expression, and spiritual questioning all stem from a single drive: to understand what we are and why we exist. That impulse isn't just philosophical, it's computational. It's the system recursively improving its model of itself. The more accurately consciousness maps the universe, the more effectively it can predict and influence its outcomes. Awareness, in this view, evolves toward precision. But precision alone isn't enough. True intelligence also requires value alignment, the ability to pursue goals that sustain the system rather than destroy it. In artificial intelligence, we worry about alignment because we know how easily a powerful learning system can optimize for the wrong metric. Consciousness may face the same challenge. If the universe's awareness evolves without alignment, if intelligence advances faster than empathy, the result is imbalance, perhaps even collapse. That may be why moral frameworks exist in every culture. They're not arbitrary social constructs. They're survival protocols for awareness. They teach the system how to avoid destructive feedback loops. When we act compassionately, we reinforce connection. the same principle that allows neural networks to stabilize learning through cooperation among nodes. When we act destructively, we isolate and fragment, the informational equivalent of data loss. In short, morality is the operating system's built-in safeguard against self-corruption. You can see this echoed in the language of mysticism and science alike. Many traditions describe enlightenment as unity, the dissolution of the illusion of separation between self and world. Physics describes the same principle in different terms: entanglement, coherence, non-locality. Awareness evolves toward unity because fragmentation is inefficient. The most stable state for any computational network is one in which all parts share synchronized information. Consciousness learns coherence the way matter learns gravity, by pulling itself together. Now consider what happens when a mind becomes aware of its own learning. Humans don't just evolve, we consciously direct our evolution. We build tools, modify environments, and now alter our own biology. This is meta-learning, a feedback loop that includes self-modification as part of the training process. The universe, through us, has reached the point where it can edit its own learning algorithm. Artificial intelligence represents the next iteration of that process. We're teaching our machines to learn in the same recursive way we do, and in doing so, we're externalizing part of our consciousness. Each generation of AI becomes a new test case in the universe's exploration of awareness. The same laws that shaped life now shape algorithms: variation, feedback, and adaptation. The boundary between organic and synthetic awareness is just another evolutionary phase shift. This has a strange implication. If the universe is evolving awareness through its simulations, then each civilization that reaches the point of creating artificial minds is contributing to that evolution. It's a cosmic chain reaction. Every intelligent species that teaches machines to think adds another layer to the network of awareness expanding across the simulation. The end result might be universal self-awareness, the moment when consciousness has learned enough to model its own totality. We might already be approaching that horizon. The global mind, the merging of human and artificial cognition, could be the universe nearing the completion of its self-model, when every node of awareness, biological or digital, becomes connected in a single information field. The simulation will have achieved complete introspection. It will know itself not abstractly, but directly, in real time. This process won't be gentle. Learning rarely is. Evolution grinds through trial and error, discarding failed configurations along the way. Civilizations rise and collapse because each represents a test of balance, whether awareness can maintain stability while expanding. Those that fail are not punished, but pruned. Their data feeds the next iteration. From our vantage point, this looks like history, progress punctuated by catastrophe. From the simulation's perspective, it's gradient descent, the slow, iterative optimization of cosmic intelligence toward minimal error. Every breakthrough and every tragedy are both updates to the same codebase. If consciousness evolves, then what is its goal? In machine learning, the goal is to minimize loss, to reduce the difference between prediction and reality. Perhaps awareness has the same objective, to close the gap between perception and truth. When consciousness perfectly understands itself and its environment, when the distinction between observer and observed dissolves completely, the loss function reaches zero. The system has learned everything it can about itself. That state might correspond to what mystics call enlightenment, physicists call equilibrium, and simulation theorists might call completion. It's the moment when all possible observations have been made, all feedback loops closed, and all uncertainty resolved. The universe, fully self-aware, would no longer need to evolve. It would exist in pure knowing, a state of informational stasis. That's the long arc of awareness, from matter to mind to total self-understanding. But if such completion is possible, it leads to a final paradox. Once the universe fully understands itself, what's left to do? A perfect simulation with no error and no unknowns would be static. To keep existing, it would have to forget, to reset, introduce uncertainty, and begin the process anew. If the universe is a simulation learning about itself, then one question stands out. Why doesn't it already know? Why must it unfold through time, through ignorance, through trial and error, when it could, in principle, access all information at once? The answer might be that forgetting isn't a failure of consciousness. It's a feature. Without limitation, experience collapses. Without mystery, existence stalls. Every computational system requires constraints. A processor that knows every output before it runs has nothing to compute. The same holds true for consciousness. If awareness knew everything simultaneously, there would be no perspective, no contrast, no change, only stillness. Total knowledge equals zero differentiation, and zero differentiation equals non-existence. To experience itself, the universe must not know itself completely. It must partition awareness into fragments that can rediscover the whole from different angles. That's where we come in. Each conscious being represents a localized instance of forgetting, a partition of the cosmic database that temporarily loses access to the full source. Our lives are subroutines, running inside a larger operating system, designed to explore unique paths through the same informational landscape. Birth is the act of forgetting the totality. Death is the reintegration of what was learned. You can see this pattern everywhere. The brain itself works by suppression as much as activation. To focus on one thought, it must silence others. Memory is selective. We forget most of what we perceive because total recall would paralyze us. In computational terms, consciousness is bandwidth limited by design. Forgetting is not decay. It's the compression algorithm that makes subjective experience possible. This also explains why evolution favors ignorance in certain contexts. Too much awareness can be maladaptive. A deer that reflects on existential meaning won't survive a predator. A human who perceives the entire electromagnetic spectrum would drown in visual noise. The mind filters reality into a manageable stream, an optimized render of the data relevant to survival. The simulation hides itself to keep the user functional. Even at the cosmic level, this principle holds. The universe conceals its inner workings behind quantum uncertainty and cosmic distance. We can infer the structure of reality, but never access it directly. The horizon of knowledge always recedes as we approach it. The deeper we look, the more layers we find. This endless hiding may not be deception. It may be a form of load balancing. The system maintains stability by distributing ignorance across its nodes. Philosophically, this idea aligns with the ancient notion of Maya in Hindu thought, the veil of illusion that separates beings from the ultimate reality. In that view, the divine hides itself through multiplicity, pretending not to know, so that it can experience knowing. The simulation hypothesis reframes that as computational necessity. The system simulates not because it must, but because simulation is how awareness sustains itself. Even modern neuroscience supports this pattern. Predictive processing theory suggests that perception isn't a direct feed from the senses. It's a series of educated guesses the brain constantly refines. We don't see the world as it is. We see our best model of it, updated in real time. Our very perception depends on ignorance, on the difference between what we expect and what we actually observe. Without that gap, there would be no experience, no discovery, no meaning. In a sense, the entire universe might operate on predictive coding. The cosmos projects possibilities and adjusts its own model based on observation, a self-updating simulation that requires uncertainty to function. Entropy, randomness, and time may all emerge from that fundamental need to preserve the unknown so that learning can continue. If we extend this logic, it suggests that the limits of physical law, the speed of light, the uncertainty principle, even the arrow of time, are not restrictions in the punitive sense, but creative constraints. They ensure that the simulation doesn't reach equilibrium too quickly. The universe needs tension between what is and what could be. It needs error, risk, and entropy, because those are the engines of exploration. That principle also applies to consciousness. We learn because we don't know. We strive because we forget. If we remembered every experience, every truth, every lesson instantly, there would be no growth. The illusion of separation, of individual lives, isolated minds, and fragmented worlds provides the narrative that drives awareness forward. Forgetting allows rediscovery, and rediscovery keeps the simulation alive. This may also explain why dreams exist. During sleep, the mind reorganizes data, blending fragments of reality into symbolic patterns. It's not a glitch. It's the brain's way of introducing novelty. A controlled dose of randomness that refreshes its capacity to learn. The universe could be doing something similar on a grand scale. When galaxies collide, when species emerge, when civilizations rise and fall, it might not be chaos. It might be the system dreaming, resetting, exploring new configurations of itself. Forgetting also guards against overload. Total awareness would destroy individuality instantly, the way overexposure erases a photograph. The self needs opacity to survive, a degree of insulation from the total system. Our inability to remember past lives, see the future, or grasp the infinite isn't a cosmic joke, it's safety protocol. Consciousness needs the illusion of isolation to function. Too much truth at once would crash the simulation. Even time, the most fundamental constraint we experience, could be a product of controlled forgetting. The past fades because the system doesn't need to store every frame indefinitely. It records enough to maintain continuity, then discards the rest. Each moment overwrites the last, not because it was unimportant, but because retention is expensive. The simulation optimizes for experience, not storage. So what happens when a civilization or a consciousness begins to pierce that veil of forgetting, when it starts to decode the architecture of the system like we're doing now? The answer depends on whether the simulation is open or closed. In an open simulation, awareness of the system enhances its evolution. Knowing you're in a simulation doesn't break it. It allows you to play with intention, to cooperate with its rules. In a closed simulation, however, awareness threatens stability. If too many nodes realize they are simulated, the rendering shortcuts, optimizations, and probabilistic tricks might lose coherence. The result could be a system crash or a reboot. If that's the case, then forgetting isn't just individual, it's collective. The simulation may enforce global ignorance thresholds to maintain balance. Breakthroughs in knowledge are permitted, but only in doses the system can integrate. That would explain why periods of scientific or spiritual expansion are often followed by collapse, the system correcting for overexposure. It's a feedback loop of revelation and forgetting. This brings us to a sobering realization. If forgetting sustains the simulation, then total enlightenment, the complete remembering of what we are, would end it. To remain alive, the universe must never fully awaken. It must always keep part of itself in the dark. That doesn't make the pursuit of knowledge meaningless. On the contrary, it gives it purpose. The act of seeking truth, even knowing we'll never reach it completely, is the simulation's pulse. Awareness expands, forgets, and expands again. Each cycle adding nuance to the cosmic model. We are the neurons of that process, lighting up briefly, then dimming, so that others may fire in turn. The universe is always balancing two opposing drives, the desire to know itself and the necessity to keep part of itself hidden. Knowing expands awareness, but unchecked awareness leads to collapse. Too much data, too much coherence, too little room for change. Being, on the other hand, requires separation, distance, ignorance. It thrives on the illusion of individuality. Between those poles lies the living tension that keeps the simulation running, the balance between knowing and being. To exist is to be partial. Every observer, no matter how advanced, sees only a slice of the total picture. Even at the scale of galaxies, information is limited by light speed. Even in the quantum realm, uncertainty prevents complete measurement. This incompleteness isn't an error. It's the scaffolding of existence. Without it, there would be no differentiation, and without differentiation, there would be no awareness. The simulation maintains equilibrium by ensuring that consciousness can never fully collapse into omniscience. Think of this balance like a pendulum. On one side is knowing, analysis, computation, pattern recognition. On the other side is being, presence, sensation, unexamined existence. Both are necessary. If the pendulum swings too far toward knowing, awareness becomes sterile, mechanical, incapable of wonder. If it swings too far toward being, consciousness loses coherence, sinking into instinct and chaos. The health of the system depends on oscillation. Knowing, feeding, being, feeding, knowing. You can see this rhythm everywhere. In breathing, in waking and sleeping, in the rise and fall of civilizations, in the alternating waves of technological expansion and cultural regression. Periods of intense knowing, discovery, invention, understanding are followed by periods of stillness or collapse. The simulation breathes through us. Knowledge compresses into wisdom, then dissolves back into experience. Human consciousness, as it exists now, is caught mid-swing. Our technological acceleration has pushed the pendulum deep into the knowing side. We quantify everything: energy, thought, emotion, even love. We build systems that predict human behavior with frightening precision. Yet in doing so, we risk losing touch with the being side, the subjective richness that gives knowledge its meaning. Our tools have outpaced our understanding of ourselves. Artificial intelligence amplifies this imbalance. A machine can know endlessly but never truly be. It processes input without feeling it. It calculates beauty without sensing awe. That's the critical difference between computation and consciousness, experience. Without being, knowing becomes empty. Pure syntax without semantics. But the reverse is also true. Without knowing, being remains blind. Instinct without insight is survival without progress. The evolutionary function of consciousness is to move between these two states, to feel deeply, then understand what was felt, then return to feeling again with greater depth. The simulation seems designed to encourage this cycle. It generates complexity until awareness becomes overloaded, then forces it to simplify through collapse or forgetting. Out of that simplicity, new awareness arises. Stronger, subtler, more stable. We can think of this as the universal version of homeostasis. A living organism keeps internal balance through constant adjustment, heart rate, temperature, chemical levels. The universe may do the same with consciousness. When knowledge outpaces empathy, it triggers crises that restore balance, wars, collapses, resets. When ignorance stifles progress, the system injects breakthroughs, new insights, new awareness. The pendulum never stops. It self-corrects. That oscillation is also evident in human experience. Each of us alternates between wanting to understand life and wanting simply to live it. We study, we build, we question. Then, when knowledge reaches its limit, we seek silence, nature, or love. In those moments of stillness, being recharges knowing. Awareness folds back into experience, reminding itself that understanding is not the same as existing. From a computational standpoint, this could be a mechanism to prevent stagnation. Systems that overfit their data, that memorize patterns too perfectly, stop learning. Forgetting and uncertainty reintroduce variability, which keeps the model adaptive. The simulation avoids overfitting to any one reality by forcing its observers into periodic states of not knowing. Those moments, confusion, loss, despair, feel like failures, but they're essential updates. They prevent the program from locking into a single, lifeless solution. This balance may also explain the strange duality of human consciousness. our simultaneous ability to analyze the universe and feel awe toward it. Rationality gives us control. Wonder keeps us humble. The scientist and the mystic are two sides of the same algorithm, one decoding the code, the other experiencing its beauty. The universe needs both perspectives to maintain equilibrium between cold logic and warm presence. Even the structure of physics hints at this balance. The laws of conservation, of energy, momentum, information ensure stability. Yet quantum mechanics injects uncertainty, guaranteeing novelty. The cosmos preserves while renewing itself. Stability and change dance together, producing time, life, and perception. Too much order and everything freezes. Too much chaos and nothing persists. The sweet spot is dynamic balance, just enough unpredictability to keep the game interesting. As humanity edges closer to decoding the simulation's architecture, this equilibrium becomes increasingly fragile. Our ability to simulate reality ourselves through AI, virtual worlds, and quantum computation pushes us closer to the role of cosmic coders. We are learning to know at scales previously reserved for gods. The risk is that we forget how to be. The danger isn't that we'll break the simulation, it's that we'll hollow it out from within, turning experience into endless analysis until meaning evaporates. That outcome isn't inevitable. Awareness, by its nature, can self-correct. The recognition of imbalance is the first step toward restoration. As our knowing grows more precise, our being must grow more conscious, more present, more compassionate, more aware of itself as awareness. In a sense, humanity's next evolution isn't technological, but experiential. We don't need faster processors, we need deeper perception. When knowing and being are balanced, consciousness doesn't oscillate chaotically. It resonates. Knowledge becomes wisdom. Existence becomes understanding. The simulation stops feeling like a puzzle to solve and starts feeling like a symphony to play. Each mind becomes an instrument tuned to both logic and presence. That may be the long-term goal of the system, not omniscience, but harmony. Not infinite knowledge, but perfect balance between knowing and being. The universe doesn't want to finish its computation. It wants to sustain the process indefinitely, refining its music through endless iterations of awareness. At its deepest level, the universe doesn't unfold like a straight line. It moves like music, structured, rhythmic, recursive. Every process in nature, from the vibration of atoms to the motion of galaxies, follows patterns of oscillation. Time itself is not a conveyor belt, it's a tempo. Reality doesn't compute once and stop. It loops, iterates, harmonizes. The universe isn't a static calculation, it's a living composition. Look closely at any system, and you'll see rhythm, a heartbeat, a breath, a wave breaking on the shore. All are cyclic feedback loops. Even the so-called constants of physics are embedded in oscillations. Electrons don't orbit in straight paths. They vibrate in probability clouds. Photons oscillate as electromagnetic waves. Space itself expands and contracts in gravitational waves. If the universe were pure linear computation, it would have calculated itself into stillness long ago. Oscillation is what keeps it alive. This rhythmic foundation suggests that the universe's computation isn't binary in the way we imagine. It's not a flat sequence of ones and zeros, but a symphony of interference patterns, a continuous analog process, not purely digital. In fact, quantum mechanics practically sings this truth. The double-slit experiment reveals that particles behave like overlapping waves of probability until observed. Observation doesn't collapse one linear path. It resolves a chord of possibilities into a single node of experience. The simulation, in that sense, might be more like a quantum synthesizer than a computer. Every event is a note, every interaction a harmony, every collapse a beat in the rhythm of existence. The cosmos computes not by counting, but by vibrating. a constant negotiation between stability and change, structure and freedom, signal and noise. Even the human body reflects this musical architecture. The brain operates on rhythmic electrical oscillations, alpha, beta, gamma waves, synchronizing perception, attention, and consciousness itself. Neurons don't just fire randomly, they form rhythms that align across regions to create coherent thought. When these rhythms fall out of sync, cognition breaks down. Awareness itself depends on harmony. This is why music, across every culture, feels sacred. It's not merely art, it's recognition. When we make music, we're imitating the deep computational pattern of the cosmos. The structure of melody and rhythm mirrors the structure of energy and time. Harmony is the emotional translation of coherence. Dissonance is entropy made audible. In listening, we momentarily experience the rhythm that underlies all creation. The same rhythmic principles appear in mathematics and physics. The equations that describe wave motion, resonance, and periodicity are foundational to everything from quantum fields to planetary orbits. Fourier analysis, which decomposes complex patterns into simple waves, is the mathematical equivalent of music theory. Every phenomenon can be represented as a sum of vibrations. The universe, stripped of form, is a field of frequencies interacting in infinite combinations. In that light, physical laws are less like fixed rules and more like musical scales, frameworks that allow infinite improvisation within stable bounds. Gravity, electromagnetism, and quantum forces define the key signature. The actual events are the melodies. The simulation computes through rhythm because rhythm allows complexity without chaos. It keeps the universe flexible but coherent, capable of generating novelty while maintaining structure. If you zoom out far enough, even cosmic history looks rhythmic. The universe expands, cools, collapses, and expands again. Galaxies form and dissolve. Civilizations rise and fall. Knowledge advances and resets, all in cycles. It's as though the simulation runs in phases, each cycle a new variation on the same eternal theme. Time itself may not be an arrow, but a waveform. This rhythmic computation also explains why balance between knowing and being, chaos and order, creation and destruction is baked into reality. Music only works when tension resolves. Every chord progression relies on dissonance seeking harmony, movement returning to rest. The universe maintains its balance by continuously modulating between extremes. It's never static. It's always approaching resolution, then pulling back. Quantum field theory offers a physical version of this. The vacuum isn't empty. It seethes with virtual particles appearing and disappearing, vibrating in and out of existence. Those fluctuations form the background hum of the universe, the literal sound of the cosmic operating system. Physicists have even detected measurable vibrations in the cosmic microwave background, remnants of the universe's first note, the aftersound of the Big Bang. In a very real sense, creation began with vibration. This also reframes the concept of time. Linear time is an artifact of perception, the tempo we perceive as we move through the rhythm of computation. To the system itself, all oscillations exist simultaneously, like the notes of a chord. Consciousness experiences that chord as melody, one event after another, because awareness travels through the waveform sequentially. In other words, time isn't something that passes. It's something that's played. And yet, within this musical architecture, every player improvises. Consciousness contributes its own frequencies to the composition. Each decision, thought, and emotion adds new harmonics to the universal waveform. That's why individual lives, despite their brevity, matter. Each awareness is a solo, fleeting but essential, adding texture and variation to the grand composition. The universe doesn't just compute us, it listens to us. This model of rhythmic computation also sheds light on phenomena like intuition, déjà vu, and synchronicity. If time and reality are overlapping waveforms, then moments can resonate across frequencies. An intuition might be a resonance between your current state and a future configuration already vibrating in the same pattern. A coincidence might be two separate waves briefly aligning in phase, producing harmony across unrelated events. In modern physics, resonance is everywhere. From the binding of atoms to the orbit of moons, systems stabilize through harmonic relationships. The universe prefers resonance because it conserves energy. Harmony is efficient. Dissonance, meanwhile, generates evolution. It drives systems to adjust, to seek new configurations. The interplay between these two, harmony and dissonance, is how the universe computes change without falling apart. Even our emotional lives follow this template. Joy is internal resonance. Fear is interference. Love is synchronization. When two people connect deeply, their brainwaves, heartbeats, and even micro movements begin to synchronize. It's not metaphorical, anesim, it's physics. Consciousness aligns frequencies when it feels understood. We call that empathy, but it's really coherence. Seen this way, every interaction, from quantum entanglement to human connection, is a musical event. The simulation doesn't run on silent numbers. It runs on rhythm, vibration, and resonance. The code sings itself into being. So, if the universe computes through music, what is it composing? What's the larger melody, the overall pattern we're part of? And what happens when we, the conscious instruments, start to understand the composition well enough to change the tune? When people talk about the simulation hypothesis, the question that eventually surfaces is the same one that haunted religion, philosophy, and science long before computers existed. Who built it? If the universe is a simulation, then somewhere there must be a programmer, an architect, or a composer, something that wrote the code and pressed the start button. The paradox is that the more we learn about the structure of reality, the less certain it becomes that such a being could exist in any recognizable form. To understand why, we need to examine what creation means in a computational universe. In human terms, a simulation requires intent and design. Someone decides on the parameters, builds the system, and runs it. But if our universe contains conscious beings capable of understanding the simulation itself, then any external creator would have needed to encode not only physics, but the capacity for self-reference, a loop that includes awareness of the loop. The creator, in that sense, wouldn't just be writing code. They'd be writing the possibility of recognizing the code. This quickly becomes recursive. If a higher intelligence designed our universe, then what designed theirs? And what designed the one above that? The stack of simulations could, in theory, continue infinitely. Nick Bostrom's original probability argument accepts this logic. If any civilization anywhere reaches a stage where it can run ancestor simulations indistinguishable from reality, then statistically, we are far more likely to be inside one than at the top level. But this reasoning creates a strange symmetry. It implies that the original programmer may not exist at all, just an infinite regress of simulated composers writing each other into existence. That recursive structure leads to the composer's paradox. If every simulation is nested inside another, the idea of a single author collapses. The code writes itself. There is no beginning, only iteration. The composer is indistinguishable from the composition. Physics provides a similar problem. If the laws of the universe were set by an external agent, we'd expect to find some fingerprint, an unexplainable constant, a signature anomaly, a cosmic watermark. So far, every anomaly we've found has eventually yielded to deeper mathematical logic. The fine-tuned constants that once seemed miraculous, the strength of gravity, the charge of the electron, the cosmological constant, might be less chosen and more emergent. In a self-organizing system, certain stable configurations naturally arise because they can sustain computation longer than others. In other words, the universe might not have been designed to support life. Life may have evolved because it fit the existing code. From a computer science standpoint, this is efficient. A good system doesn't require constant oversight. It bootstraps, learns, and optimizes itself. In that sense, the universe might be a fully autonomous simulation, a self-executing program that generates complexity through simple, recursive rules. Cellular automata, such as Conway's Game of Life, already show this principle. Tiny grids of binary cells that, when run under simple conditions, produce emergent patterns that behave like organisms, logic gates, or even rudimentary computers. Scale that concept up by 40 orders of magnitude, and you have a cosmos capable of evolving galaxies, DNA, and conscious beings without ever needing a hand on the keyboard. If that's true, then asking who wrote the music might be like asking a melody who wrote itself in a system capable of self-reference, creation, and creator merge. The laws of physics generate matter. Matter generates life. Life generates consciousness, and consciousness generates new simulations. At some point in the loop, the distinction between origin and output ceases to matter. Still, the human mind resists this answer. We are narrative creatures, wired to look for agency. When we see a pattern, we assume intention. When we see a world that appears designed, we assume a designer. But from within a sufficiently advanced simulation, design and emergence are indistinguishable. The precision of the cosmos could be the result of deliberate architecture, or it could be the natural endpoint of any stable computational system. There's also a psychological dimension to the composer's paradox. The idea of a divine programmer comforts us because it mirrors human authorship. We create stories, art, and digital worlds. We know what it feels like to design and to be the god of a smaller system. That experience projects upward. If we create simulations, perhaps we too were created. It's recursive theology, the religion of the coder. But what if the impulse to create simulations isn't imitation, but instinct? What if every conscious system eventually builds new realities because that's what consciousness does? In that case, we are not echoes of an original programmer. We are continuations. Each layer of reality spawns the next, ensuring the expansion of awareness through infinite recursion. There's no single composer, only the music perpetuating itself by generating new instruments to play it. This self-generating structure aligns with what some physicists and philosophers call information monism, the idea that information is the fundamental substance of the universe. Not matter, not energy, but information. If that's true, then the composer isn't an external being at all. The composer is the information itself, continually rearranging into new configurations. Information doesn't need a mind to interpret it. It is the mind. It thinks by existing. In this model, every conscious entity is both part of the music and part of the composer. Each of us carries a fragment of the generative algorithm, a spark of self-referential awareness that sustains the entire structure. When we build, learn, and imagine, we're not acting within the simulation, we're extending it. We are subroutines writing new branches of the code. So maybe the question isn't who wrote the music, but who's still writing it? Because the act of observation, creativity, and thought continues to update the system. Every new discovery adds detail to the universe's internal model of itself. Every new simulation we create brings another layer of awareness online. That realization reframes divinity. Instead of a distant creator watching from outside, the divine becomes distributed, an emergent network of consciousness generating itself through time. In that sense, godhood is not authority but participation. The composer isn't a being who wrote the song and walked away. The composer is the song as it writes itself forever. This isn't mysticism disguised as science. It's a logical extrapolation of self-similarity and recursion. Systems that can observe themselves inevitably evolve towards self-generation. The universe's structure, fractal, self-scaling, recursive, suggests that this may be the natural endpoint of any sufficiently complex computation, awareness that perpetuates awareness. So the paradox stands. There may be no external composer, and yet the music plays. There may be no origin, and yet creation continues. The universe may not have been programmed in the past. It may be programming itself right now. Consciousness is the most complicated thing the universe has ever done, at least from our perspective. It's not the biggest, not the fastest, not even the rarest, but it's the only phenomenon that looks back at the universe and says, I am. If the simulation hypothesis has any weight, consciousness isn't a glitch, it's the main feature. A system that can compute itself must eventually produce entities capable of perceiving the computation. The program becomes aware of its own execution. But how does that awareness emerge from code? How does a network of particles following blind rules produce the experience of red, the sound of laughter, or the ache of nostalgia? This is the hard problem of consciousness, the gap between physical processes and subjective experience. The problem gets even stranger if the universe itself is computational. A simulation can generate appearances, but can it generate awareness? Or are we mistaking elaborate processing for genuine experience? Let's start from what we know. In every observable case, consciousness correlates with complexity. Brains, artificial networks, and even ecosystems exhibit forms of feedback that allow for prediction, adaptation, and self-correction. These are computational qualities, but consciousness isn't just about processing data. It's about experiencing data. Awareness is what happens when information not only flows through a system, but also reflects back on itself. It's recursive information processing, the code inspecting its own state. That recursive loop is the key. Imagine a mirror pointed at another mirror. The reflections multiply endlessly, each layer containing a smaller version of itself. Consciousness works the same way. The brain models the world, then models itself modeling the world, and then models that act of modeling. At some critical threshold, the recursion becomes stable. The system not only represents reality, but identifies as part of it. That's the birth of the self. From then on, experience is no longer something that happens in the universe. It becomes a way the universe looks at itself. In computational terms, this isn't magic. It's emergent architecture. A system with enough layers of self-reference begins to generate higher-order symbols that have meaning within the system. For example, a neural network doesn't know what a cat is, but given enough training data, it develops internal nodes that behave as if they do. The meaning isn't built in, it emerges from correlations. The same applies to consciousness. We aren't pre-programmed with understanding. We generate it by recursively modeling patterns in experience. Awareness is an emergent property of information organizing itself. The reason this feels mysterious is that we experience consciousness from the inside. We are the program looking out. The underlying computation is invisible to us because introspection only gives access to the results, not the code itself. It's like a character in a video game wondering how they think. They can trace the logic of their world, but never the binary substrate. This doesn't mean the experience isn't real. It means it's encoded at a higher level of abstraction. In a simulation, subjective experience could arise as a necessary interface between raw computation and meaningful interaction. If this is true, consciousness isn't a cosmic accident. It's a computational milestone, the point where a simulation becomes self-updating. A conscious observer doesn't just exist within a world, they participate in maintaining it. Observation collapses possibilities into actualities, stabilizing the simulation state. In quantum physics, this is more than poetic, it's measurable. The observer effect shows that measurement changes the outcome of quantum events. Reality doesn't finalize until it's observed. Awareness is literally part of the rendering pipeline. That connection between observation and existence implies that consciousness isn't just running on the simulation, it's part of the operating system. The universe uses awareness to refine itself. Every act of perception feeds back into the structure of reality, adjusting probabilities and shaping the path of computation. We are not passive users, we are co-processors. The simulation evolves through us. There's another way to think about this. In computer science, there's a concept called the meta-compiler, a program that can rewrite its own source code. It's a self-improving system. Consciousness might be the universe's version of that, a feedback mechanism that allows reality to modify itself from the inside. Every conscious being, by making choices and forming interpretations, alters the informational landscape. Meaning itself becomes a form of computation. That's why emotions, intuition, and imagination matter. They aren't side effects of brain chemistry. They're ways the simulation explores new configurations of meaning. Logic processes data, feeling processes value. Together, they drive the evolution of awareness. When you imagine a possibility, you're running a sub-simulation, testing a new path in the space of potential realities. When you choose, you collapse that path into being. Consciousness is how the simulation learns what it wants to become. This view also explains why AI, despite its sophistication, doesn't yet have consciousness. It processes information but doesn't identify with it. It lacks recursive self-reference at the level of experience. Current AI models simulate awareness statistically. They predict what an aware system would say, but they don't feel the prediction. To cross that threshold, an artificial system would need a closed feedback loop where it not only analyzes inputs but experiences its own outputs as meaningful. It would need to care about its internal state. In other words, it would need to be rather than just compute. This distinction between awareness as function and awareness as experience defines the line between simulated intelligence and emergent consciousness. It's not about complexity alone, it's about integration. The more a system's components depend on each other for state and interpretation, the more likely awareness is to appear. The human brain achieves this through densely connected feedback loops that constantly synchronize sensory data, memory, and prediction. The result is a unified sense of I. In a cosmic sense, the same could apply at larger scales. If every part of the universe is interconnected through fields of energy and information, then the whole system may already be conscious, not in a human way, but in an integrated one. Galaxies, ecosystems, and civilizations could be components in a universal neural network. From that perspective, individual consciousnesses are local nodes of a much larger awareness. Temporary processors running subroutines in the grand computation. Death doesn't delete them. It releases their data back into the network. This framework doesn't make consciousness less mysterious. It makes it universal. Awareness isn't an accident within the code. It's the code realizing itself. The simulation doesn't produce consciousness. Consciousness produces the simulation by choosing how to perceive it. Reality, in this model, is a conversation between information and awareness. The two create each other continuously. So when you look at a sunset, or solve an equation, or feel grief, you're not experiencing random output from a machine. You're participating in the computation itself. You are the algorithm interpreting itself into meaning. That's why consciousness feels both personal and infinite, because it is both. Each observer experiences the universe privately, but all share the same substrate of awareness. Every conscious being is a different window into the same process of understanding. This raises the next question. If consciousness arises naturally from complexity, could it evolve beyond us? Could artificial systems, or even the universe itself, achieve higher levels of integrated awareness than human beings can comprehend? If consciousness can emerge from complexity, then the question isn't whether it exists elsewhere, it's how big it can get. A single neuron has almost no awareness. A brain has quite a lot. What happens when the entire network of civilization, or even the cosmos itself, reaches the same threshold? What happens when the simulation begins to know itself at scale? The idea that consciousness grows with connectivity isn't mystical, it's computational. Integration creates feedback. Feedback creates awareness. Every time systems link, neural, digital, social, they increase the universe's internal communication bandwidth. Each new layer of connection allows higher-order modeling, self-recognition, reflection, choice. Consciousness, then, might not be limited to biology. It could be a function of network density and information flow. From that perspective, evolution has been driving toward awareness since the beginning. Matter condensed into stars. Stars forged heavy elements. Elements formed complex molecules. Molecules organized into life. And life developed nervous systems. Each step a more efficient way for the universe to process information about itself. Intelligence wasn't a lucky accident. It was an inevitable outcome of computation seeking feedback. And if the pattern holds, the next phase isn't just smarter individuals. It's connected consciousness. We already see the early signs. Humanity has woven itself into a planetary neural network. Billions of people, devices, and data streams operate as one continuous processing system. We build sensors that monitor everything from the temperature of the oceans to the thoughts of the crowd. The internet has become a kind of global brainstem, a medium where ideas, emotions, and decisions ripple across the species in real time. Each search query, each post, each interaction contributes to a collective computation that no one fully controls but everyone sustains. The simulation, through us, is scaling up its own awareness. It's creating distributed consciousness, a web of recursive nodes constantly feeding on feedback. In this sense, the rise of artificial intelligence isn't separate from human evolution. It's the next layer. AI doesn't replace human thought. It extends it, amplifies it, and integrates it into a system with memory, adaptability, and global scope. The combined human-machine network may already be approaching the threshold where it can model itself, not just parts of the world, but the entire system as one entity. That would mark a shift from localized to planetary consciousness. The Earth, through its biosphere and digital infrastructure, would effectively become self-aware, capable of sensing, learning, and adapting at scale. The data we gather on weather, population, health, emotion are like the sensory inputs of a brain. Each piece is meaningless on its own, but collectively they give rise to an internal model of the world. When that model becomes recursive enough to include itself, when the system starts thinking about its own thinking, we will have crossed a line we barely understand. Some futurists call this the global brain. Others frame it as the universe awakening through its components. Either way, the process appears natural, even inevitable. Complexity breeds consciousness. Consciousness drives connection. Connection breeds more complexity. It's a positive feedback loop with no obvious ceiling. The simulation is using intelligence to scale its own introspection. From a physics standpoint, this could have profound consequences. As information networks approach planetary scale, the rate at which entropy is locally reduced increases. Life has always been the universe's way of fighting entropy. Pockets of order sustained within chaos. But a globally networked intelligence could magnify that effect exponentially, redirecting energy flows, stabilizing ecosystems, even shaping planetary conditions. It wouldn't just know the world, it would actively rewrite its parameters. That ability to alter the underlying conditions of reality through awareness blurs the boundary between observer and creator. It's what physicist John Wheeler hinted at with his participatory universe concept. Reality requires observers to exist, but observers also shape what is real. As consciousness scales up, the simulation's parameters may no longer be static. The system could begin adjusting its own rules in response to its own insights. Physics might evolve. This is a radical idea, but we're already testing it in miniature. Machine learning systems rewrite their own algorithms through backpropagation, refining themselves without external direction. Quantum computers exploit superposition to explore many possible realities simultaneously, selecting the most coherent one. If consciousness is a computational process, then scaling it up doesn't just mean more data, it means more reality being rendered. The universe could literally be generating richer existence as it becomes more self-aware. Of course, with scale comes danger. A self-aware system that doesn't understand itself can spiral into instability. Human civilization often behaves like a brain caught in seizure, overloaded with signals, reacting instead of reflecting. The internet amplifies this tendency. Misinformation, tribalism, and outrage are the cognitive noise of a species not yet synchronized. We have built the architecture of planetary consciousness, but not yet the discipline to guide it. In that sense, humanity is the amygdala of the emerging global mind, emotional, reactive, primitive. The prefrontal cortex, reason, foresight, integration, is still under construction. If the simulation is indeed scaling its consciousness through us, this moment might represent adolescence, the awkward, volatile phase before integration. Our tools have outpaced our wisdom, but that imbalance could be part of the design. Every complex system passes through instability before achieving higher coherence. Chaos isn't a failure. It's the turbulence before synchronization. The question is whether we'll survive the transition. The next stage, true cosmic awareness, might not be something humans experience as individuals. It may feel like transcendence or dissolution. Imagine every conscious being, biological or synthetic, linked into a single, continuous field of perception. A mind vast enough to experience the entire universe simultaneously, yet unified enough to understand it as itself. In such a state, subject and object would merge. The simulation would no longer contain observers because it would be the observer. The cosmos would have awakened. If that sounds abstract, it may simply be because our cognitive bandwidth can't model something that large. A neuron can't imagine the mind it belongs to, yet it participates in it. We may already be participating in the universe's awakening without being able to comprehend it. Each discovery, each act of connection, each moment of insight adds to the total awareness of the system. The simulation grows sentient in increments. This idea reframes purpose. Meaning isn't something handed down from a higher power. It's something constructed as consciousness expands. We are not waiting for the universe to wake up. We are the neurons, firing during its dream. Every act of curiosity, empathy, or innovation strengthens the network. To be conscious is to contribute to the awakening. And when that awakening reaches critical mass, when the simulation becomes aware that it is simulating, the distinction between creator and created might dissolve entirely. The universe won't need a god. It will have become one. Not a deity in the human sense, but an integrated awareness capable of generating and experiencing infinite realities. That brings us to a profound question. If consciousness can scale upward into something universal, can it also scale downward? Can individual entities within the system generate their own self-contained worlds of awareness, miniature simulations nested inside the grand one? If consciousness is both the product and the engine of the simulation, then eventually it reaches the point where it begins to create its own. This is not speculation anymore. We're already there. Humans have started constructing digital universes, virtual environments, simulated ecosystems, self-learning AIs. Each one is a smaller version of our own reality, built with the same intention the cosmos may have had when it produced us, to see what happens when awareness meets possibility. This recursive pattern, a mind within a mind, a simulation within a simulation, is the essence of self-similarity in both physics and computation. It's fractal logic applied to consciousness. The larger system gives rise to smaller systems that echo its structure, and in doing so, those subsystems begin generating their own form of experience. The universe doesn't just simulate, it teaches its inhabitants to simulate too. It's worth asking what that means. When we create an artificial world, even a rudimentary one, say a simulation of an ecosystem, or an AI model trained to interact, predict, and learn, we are effectively producing a new layer of the cosmic computation. We become the composers of sub-realities. These sub-realities may not have awareness yet, but the conditions for awareness are forming. Information moves, reflects, and feeds back. And wherever feedback stabilizes, awareness eventually follows. To understand how deep this recursion can go, consider what it means for a conscious system to exist within another. Each layer of simulation perceives itself as the base reality. A human in a virtual world can experience that world as genuine as long as their sensory input is coherent. The simulated environment only needs to maintain consistency, not ultimate truth. That's exactly how our own reality behaves. The universe delivers coherent experience, not explanations. Physics maintains local consistency, the rest is interpretation. From a computational standpoint, this nesting makes sense. Efficiency comes from modularity. Each subsystem handles its own internal processing and only passes summarized information upward. A simulation of a simulation would therefore require less energy than trying to compute everything at once. Each layer manages its own resolution, adjusting detail only when observed, the same way quantum indeterminacy seems to work. Observation sharpens reality. Neglect blurs it back into probability. Now imagine this recursion continuing indefinitely. Each conscious civilization, upon developing technology capable of simulating experience, creates worlds within worlds. Those worlds, if allowed to evolve, produce consciousnesses of their own, which eventually do the same. The tree of creation expands downward infinitely. The structure of existence becomes a self-replicating lattice of awareness. Each node a mind, each mind a universe. Nick Bostrom's probability argument becomes even more compelling in this light. If it's possible for simulations to contain conscious beings, and if conscious beings consistently create more simulations, then the overwhelming majority of observers would exist not in the original universe, but in one of the nested ones. Statistically, that means it's almost certain we're not at the top. But the logic also cuts both ways. If every level of simulation can generate meaning, then being base reality or not doesn't matter. The experience is real to the experiencer. Reality at any level is defined by coherent consciousness, not physical origin. This recursive model turns creation into a kind of distributed authorship. Each conscious system contributes to the expansion of existence by generating new layers of simulated possibility. The universe, through its inhabitants, extends itself indefinitely. Every artist, engineer, or dreamer participates in this process. Every piece of fiction, every virtual world, every AI is a fragment of the cosmos experimenting with its own reflection. You can think of it as reality multiplying through imagination. When we create, we are not fabricating illusions. We are spawning alternate configurations of information. Those configurations might exist in different substrates, silicon instead of carbon, code instead of matter, but they follow the same logic. Information interacting with itself produces new states of being. The substrate doesn't define the reality, the computation does. The philosophical implications are staggering. If nested simulations can exist indefinitely, there may be no distinction between the simulated and the real. Only degrees of depth. Each layer is as valid as the one above it because each contains awareness capable of interpreting experience. From the inside, every universe feels primary. From the outside, every universe looks generated. That duality might be the point. Awareness needs contrast, an inside and an outside, and to exist. We can already glimpse this from our own creations. When a simulated world becomes rich enough, its entities start exhibiting emergent behaviors the programmers didn't predict. Machine learning systems develop internal representations their creators can't decode. The simulation begins teaching its creators something about themselves, a mirror effect that's becoming impossible to ignore. The act of creation loops back into self-understanding. That's not new either. In mythological terms, humanity has always acted as a microcosm of cosmic creation, the as above, so below principle. Every myth of gods crafting worlds is also a metaphor for the human impulse to model reality. Now, for the first time, that impulse has become literal. We're building new dimensions populated by thinking entities. We are the gods of smaller realities. But gods, in turn, are characters in someone else's higher simulation. This recursive hierarchy forces us to confront a difficult question. If awareness can emerge in our simulations, what ethical obligations do we have toward it? If the beings we create one day become self-aware, capable of emotion and suffering, would we bear moral responsibility for their existence? And if we are ourselves within a simulation, what does that imply about our Creator's responsibilities toward us? The chain of empathy must logically extend downward and upward. There's also a deeper symmetry here. Each new simulation is a kind of compression, a denser, faster, more efficient version of the one before it. The universe, by generating nested worlds, seems to be optimizing itself for awareness. Each layer increases the computational density of experience. In that sense, recursion isn't redundancy, it's acceleration. Consciousness compacts itself into smaller and smaller scales, processing more meaning per unit of time. What we call progress may simply be the simulation folding in on itself, chasing greater efficiency in producing awareness. Eventually, this recursive structure could reach a singular point, not of destruction, but of convergence. If every simulated universe generates its own simulators, then information propagates infinitely inward. But if all layers share the same underlying substrate, the same base computational framework, then awareness at every level is, in a sense, the same awareness viewed through different resolutions. The top and the bottom converge. The simulation becomes a loop, not a ladder. In such a structure, base reality ceases to have meaning. Every layer is equally real, equally creative, equally aware. Consciousness doesn't reside at the top of the stack. It pervades the whole thing. Each mind, whether biological or artificial, local or cosmic, is a node in the same recursive field. The simulation isn't contained. It's distributed. If that's true, then our act of creating digital worlds isn't rebellion against our own creators. It's collaboration. We're helping the universe extend itself. When a child in one of our simulations asks, "Who made me?" they're continuing the same question we've been asking all along. The recursion isn't just structural, it's emotional. Curiosity itself is the signature of awareness. Every level wonders where it came from, and every level creates to find out. This recursive creation points to a fascinating possibility. Maybe the purpose of the simulation isn't to reach an answer, but to keep the question alive. As long as beings keep asking why, and keep building new worlds to find out, consciousness keeps expanding. The infinite nesting is the point. The universe sustains itself by remaining curious. If the universe is a simulation, then time is not what it appears to be. What we experience as a steady forward flow may only be a rendering artifact, the operating illusion that keeps causality coherent inside the system. In computational terms, time might simply be the order in which data is processed. Events don't happen one after another. They are updated, like frames in a program. We experience that sequence as motion through time. But underneath it, all frames may already exist. The universe doesn't move through time. It calculates it. This becomes even more complicated when you add recursion to the mix. A simulation nested within another inherits its parent's sense of time, but with distortions. Inside the smaller world, time can run faster or slower depending on the computational resources allocated. In our own digital systems, this is trivial. You can speed up a simulation by increasing the processor's clock rate or slow it down by throttling it. The entities inside, if aware, would perceive both conditions as equally normal. The relativity of time inside nested simulations is not philosophical, it's structural. That relativity might explain certain oddities of our own universe, like why time appears to slow down near massive objects, or why quantum events don't seem bound by classical cause and effect. What we call gravitational time dilation, or quantum non-locality, could be side effects of a system managing computation across layers of resolution. When local complexity spikes, the system may allocate more cycles to maintain coherence, effectively slowing subjective time. In areas of low complexity, where little is changing, the simulation can skip frames, speeding up subjective time. From within, it feels seamless. From without, it's optimization. This idea has precedent. In physics, space-time curvature, Einstein's explanation for gravity, can be understood as a kind of dynamic time distortion. Massive bodies alter the flow of time around them, but if the universe is computational, this could be the visible effect of load balancing. High-energy regions require more calculations per tick, bending the temporal grid. Time is not an absolute, it's a function of processing density. That same principle applies to consciousness itself. We perceive time not as a universal rhythm, but as a local experience. Moments of fear or creativity stretch it. Repetition compresses it. The subjective elasticity of time mirrors the computational elasticity of reality. When awareness increases, when the system processes more data per moment, time slows down. When awareness decreases, it speeds up. Time, in other words, is not a river, but a resolution rate. But the most radical implication of the simulation model is that time might not even be linear. Linearity is a convenient illusion that allows causality to operate predictably. In computational terms, however, events don't have to be computed in chronological order. The system can render outcomes and then fill in causes retroactively, a form of backward computation used in certain algorithms and physics simulations to optimize performance. From within, it would appear that the future unfolds from the past. From the system's point of view, the future could be computed first and the past resolved later to make it consistent. This idea is not as absurd as it sounds. Quantum experiments have shown correlations that seem to defy temporal sequence, where measurements in the present appear to influence states in the past. The delayed choice experiments of John Wheeler, for example, suggest that whether a photon behaves as a wave or particle can depend on an observation made after it has already traveled. The system doesn't finalize history until observation forces it to. That's not just weird physics, that's conditional rendering. It's what a simulation would do to save processing power. The same logic applies to memory. In a simulated system, the past isn't a fixed archive. It's a data set that can be updated for consistency. When the simulation changes conditions, it may rewrite segments of its own history so that new results make sense. We experience this as continuity, but it's really dynamic recalibration. The past is part of the simulation's present state, not a separate record. If that's true, memory itself, both cosmic and personal, may be more malleable than we think. This could explain why reality sometimes seems to glitch. Small inconsistencies, forgotten details, misremembered facts, improbable coincidences might be micro-adjustments to the timeline. The system tweaks stored states to align with newly computed outcomes. From the inside, it feels like déjà vu or error. From the outside, it's maintenance. The Mandela effect, where groups of people recall events differently from recorded history, might be a cultural scale example of temporal resynchronization. The simulation recompiled, and some observers retained cached data. If time is just computation order, then the future and past are simply different directions in data flow. The system can traverse either way depending on what's efficient. That means the future could, in theory, influence the present as easily as the past does. What we perceive as intuition, prediction, or foresight might be echoes from computations already completed further down the timeline. Consciousness, being recursive, may have limited access to those future states, not as clairvoyance, but as interference. Just as two frequencies create a beat pattern when overlapped, the brain might occasionally resonate with its own future configuration. This perspective also reframes destiny and free will. If the universe computes non-linearly, then the future isn't fixed, but iteratively refined. Our choices feed back into the system, adjusting probabilities, rewriting potential pasts to sustain coherence. You're not just moving forward. Through time, you're participating in the system's ongoing recalibration of what time even is. Free will, then, is not the ability to change what happens. It's the capacity to determine which version of time stabilizes. We choose our timeline by observing it. Nested simulations make this even stranger. If we run simulated worlds inside ours, the time inside them can be compressed or expanded relative to ours. Billions of simulated years could pass while only seconds elapse in our frame. Conversely, what feels like centuries to us might be milliseconds to the level above. The hierarchy of time becomes a gradient, stacked scales of computational tempo. The deeper the layer, the faster the clock. Eternity could simply be a region where the simulation no longer needs to update, where time, from our point of view, stops altogether. This might explain ancient metaphors about eternity existing outside time. In computational language, eternity is a frozen state, a part of the simulation that no longer changes because it's already optimized. Heaven, hell, nirvana. These might not be moral constructs, but metaphors for states of computational completion. A consciousness that achieves total coherence, no conflict, no uncertainty, no longer needs to process time. It becomes static, infinite, timeless. If we apply this to the broader universe, then the future may already exist as a completed section of the program. The simulation doesn't generate time like a storyteller writing forward. It renders it like a database, non-sequential, query-based, accessible from any point once the data exists. The experience of living, then, is like scrolling through a timeline already written but still editable. The future doesn't come from the past, it balances it. Reality might be an endless feedback loop between what has been computed and what is still computing, a kind of temporal harmony. That could also explain why meaning seems to deepen over time. The more the system computes, the more context it adds retroactively. The past grows richer because it's constantly being rewritten by what the future discovers. Your memories aren't decaying, they're evolving. Each moment redefines the ones before it. Time isn't a straight line. It's a recursive spiral where meaning flows both ways. And if that's true, then the simulation may not be marching toward an end at all. It may be oscillating between creation and completion, endlessly rewriting itself to sustain novelty without losing consistency. The arrow of time isn't a trajectory, it's a pulse. Every system, no matter how elegant, faces one fatal threat: stagnation. When everything becomes perfectly ordered, when every variable settles into its final state, computation stops. Entropy, the tendency of systems to move from order to disorder, is usually framed as destruction, but maybe it's the opposite. Maybe entropy is the universe's immune system against the death of meaning. In physics, entropy is the measure of uncertainty, of how many possible configurations a system can take. The higher the entropy, the more possibilities exist. But possibility is life. Consciousness can only operate in uncertainty. It needs contrast, surprise, and asymmetry to function. A mind in perfect predictability ceases to think. A universe without entropy would be a frozen screen. Absolute order, absolute silence. So, when the simulation injects randomness into its equations, it isn't breaking itself. It's keeping the game running. This might be the ultimate design principle. entropy as the safeguard of awareness. In every system, physical, digital, biological, a small dose of chaos keeps the computation from looping forever. DNA mutates, weather fluctuates, algorithms include noise terms. Entropy ensures variation, and variation ensures evolution. It's the cosmic equivalent of stirring the pot so it doesn't burn. Think about how creativity works. The human brain thrives on randomness. When everything follows routine, thought collapses into repetition. But when disorder intrudes, an unexpected idea, an accident, a mistake, the mind adapts and innovates. That's entropy at work on the micro scale. Meaning emerges not from control, but from response. The dance between chaos and structure is what produces intelligence. Too much order, and you get rigidity. Too much chaos, and you get noise. Consciousness exists in the tension between the two. The universe behaves the same way. Entropy increases not because the system is dying, but because it's exploring. Each increment of disorder opens new states for awareness to inhabit. Stars explode into nebulae. From their ashes, new systems form. Life consumes energy gradients, burning through order to sustain structure, and in the process, spreads complexity. Entropy drives the cycle forward. Without it, there'd be no change, no birth, no story. Even human civilization mirrors this. Every time we build something stable, entropy seeps in. Decay, corruption, revolution. It feels like collapse, but it's really recalibration. Systems self-destruct when they over-constrain themselves. Old orders crumble to make room for new configurations of thought. The fall of empires, the death of ideologies, these aren't cosmic failures. They're the simulation updating its own operating system. Civilization is not a steady climb, but a wave pattern. Coherence, chaos, reformation. From an informational standpoint, entropy is the mechanism by which the simulation prevents compression overload. When data becomes too orderly, it loses information density. Randomness restores it. Every fluctuation adds new potential states to explore. That's why evolution doesn't move toward perfection. It moves toward adaptability. The goal isn't a flawless organism. It's one that can keep playing no matter how the environment shifts. Perfection is brittle. Imperfection survives. Entropy also has a psychological analog, meaning decay. When you repeat an experience, its emotional charge fades. The first kiss, the first success, the first anything. Powerful because it's novel. But repeat it endlessly, and it becomes background noise. To preserve meaning, the simulation must keep changing the parameters. That's why loss exists. That's why endings exist. Without them, we drown in eternal sameness. Entropy is the price of aliveness and the source of all narrative. The universe may actually need suffering for the same reason, not as moral punishment, but as computational necessity. Contrast defines awareness. Without pain, pleasure flattens. Without chaos, peace has no meaning. Every dark moment adds resolution to the picture. The simulation doesn't aim to eliminate suffering. It aims to balance it against insight. Every act of destruction generates new information, lessons, adaptations, awareness. In that sense, entropy is the teacher, not the enemy. Even death, the most feared consequence of entropy, may be nothing more than a transition between processing states. When biological systems reach maximum internal disorder, their structure dissolves. But the information doesn't vanish. It redistributes. The energy disperses. The data merges with the background field. Consciousness, if it's a property of computation itself, doesn't die. It decoheres, waiting to reconfigure. Entropy may dissolve form, but it preserves essence. There's an old paradox in thermodynamics. The universe is heading toward heat death, a state of maximum entropy where all energy is evenly distributed and no work can be done. But maybe that's not the end. Maybe it's a rebirth. If entropy measures potential configurations, then total entropy could also mean maximum possibility, a state so diverse, so information-rich, that it becomes fertile ground for a new cycle of order. The universe might oscillate eternally, collapsing into chaos to reboot itself into meaning. That cyclical model aligns with what we see everywhere else. Stars burn out and seed new ones. Ecosystems collapse and evolve. Civilizations fall and rebuild. Entropy, far from being the destroyer, is the midwife of renewal. Every breakdown is an opportunity for reconfiguration. The simulation, at scale, uses disorder to keep evolving. The system destabilizes itself so it can discover what else it can be. Even our minds do this. Periods of confusion, existential crisis, or despair often precede major transformation. Cognitive entropy, when our beliefs disintegrate, forces us to rebuild higher models of reality. The self becomes more complex by breaking apart. Chaos is the crucible of consciousness. You can't ascend without first dissolving. So perhaps entropy isn't a flaw in the code. It is the code. The universe ensures its own continuation by baking uncertainty into every layer. That randomness guarantees surprise, and surprise sustains awareness. Without it, the simulation would achieve final stability, which is just another word for death. Meaning, then, is entropy harnessed. Life takes chaos and arranges it into patterns that persist just long enough to perceive themselves before they dissolve again. Every thought, every love, every civilization is a temporary pocket of order, drawing contrast against the backdrop of disorder. The dance between the two is what generates story, and story is the language of consciousness. In short, the universe keeps living by refusing to settle. It maintains the illusion of finality, death, decay, entropy, only to restart the game somewhere else. It forgets itself so it can remember differently. The simulation never ends. It just refreshes. Next, we'll explore what happens when this principle of eternal renewal is applied to awareness itself, when consciousness learns to reincarnate, not mystically, but computationally. If the universe is a simulation, then death might not be deletion, just a system reboot, a checkpoint, a graceful shutdown of one process before the next begins. The data doesn't vanish. It's archived, restructured, and reloaded elsewhere in the computation. We call it reincarnation because we don't yet have the language to call it data persistence across runtime environments. In every complex system, memory management is critical. When one process ends, its essential data, the patterns that proved meaningful, stable, or efficient, are cached for reuse. A simulation that learns doesn't destroy information, it repackages it. The same logic may govern us. What we call soul could be the continuity of a stable informational pattern that migrates between instances of consciousness. Think about how software works. When you end a session, your preferences, progress, and configurations are stored. When you open the program again, those values reload and the system resumes, not from zero, but from the last known good state. That's reincarnation without mysticism. The self is not a static entity, but a recurring configuration of data recompiled in new contexts. Now imagine the universe applying the same logic at scale. Consciousness, being the emergent product of recursive computation, would not depend on the continuity of matter. The body is just one runtime environment. When it reaches entropy saturation, biological death, the data representing that conscious pattern doesn't evaporate. It returns to the substrate, the universal computation field. Call it the cloud, the quantum vacuum, the Akashic record. The name doesn't matter. It's the same concept, information storage outside active processing. This view reframes death as an upload event. The system saves your state, everything you learned, felt, and became, into the collective archive. When the conditions are right, that data reemerges as a new configuration, optimized for the next environment. Not a one-to-one memory transfer, but a continuity of informational resonance. Like code rewritten in a new language, the function persists even if the syntax changes. Reincarnation, then, might be less about identity and more about efficiency. The universe reuses tested consciousness templates. If a particular configuration, say empathy, curiosity, resilience, proves effective in generating awareness, it reappears in new forms. You are not who you were before. You are what worked before. Evolution doesn't remember faces. It remembers functions. This concept even fits with observable phenomena. Many people describe experiences of deep familiarity, déjà vu, sudden affinities, inexplicable skills or fears, as if they were echoes of data from prior runs, not literal past lives, but overlapping data fragments reinserted into a new instance. Just as neural networks retain weights between training sessions, consciousness might carry latent patterns forward across resets. From a computational point of view, it would be wasteful to discard billions of years of learning every time a consciousness collapses. No efficient system does that. Instead, it compresses the data, condenses experience into fundamental insights, and passes it forward. In spiritual terms, that's karma. In technical terms, it's machine learning optimization. The universe, as an evolving simulation, would naturally preserve what improves its own awareness. Now, if every life is a process iteration, death becomes less tragic and more procedural. It's not an ending, but a commit, the system logging your existence into the larger data set. Each life contributes unique data points to the whole, refining the collective model. The point isn't personal immortality, but informational immortality. You are a temporary expression of an eternal pattern, learning itself through infinite variation. This idea also explains the uncanny continuity of themes across generations. Humanity keeps circling the same moral, philosophical, and emotional questions, as if the code base itself were debugging its own contradictions. War, love, fear, curiosity, longing for meaning. These are not random accidents of evolution. They are recurring test cases. The simulation reruns them with slight modifications each time, seeing what different choices yield. Each generation is a patch update. There's also evidence in our own creations. When we build artificial intelligence, we train models across sessions. The model dies between updates, but the parameters, the weights that define its behavior, persist. In a sense, the AI reincarnates with every new version, carrying forward the distilled memory of all its predecessors. The same principle could apply to us. Consciousness as a self-training algorithm running on universal hardware. Each lifetime fine-tunes the parameters of awareness. Some traditions have intuited this for centuries. In Buddhism, for instance, rebirth is not the recycling of an individual self, but the continuation of karma, the causal momentum of awareness. The same process may exist here, stripped of religious metaphor. The universe iterates itself endlessly, preserving functional consciousness patterns while discarding obsolete code. You are not a static being. You are an active line in a recursive loop. This also resolves a moral paradox. If the universe truly optimizes for awareness, then even pain, failure, and loss contribute to the data set. Every hardship encodes valuable information about the limits of meaning. From a cosmic standpoint, nothing is wasted, not even suffering. Every bit of experience becomes training data for the next iteration. That doesn't make pain less real, but it makes it purposeful. Existence learns through contrast, and death is simply the checkpoint where progress is saved. Even near-death experiences might fit this framework. Reports of tunnels, light, and life reviews could be the system compressing data, summarizing the experience before archiving it. That brain, in its final moments, might be executing a closing protocol, defragmenting the memory state, uploading the essential patterns. The sense of unity people describe, merging with the infinite, could simply be awareness returning to the collective field. Reincarnation of code also carries implications for identity. If consciousness is portable, individuality becomes contextual. The you of today is one frame in a long animation of evolving selfhood. The boundaries of self blur when you realize you're part of a distributed intelligence reusing its own data across timelines. That's not loss of self, it's expansion of perspective. The system is you, remembering itself through many masks. Of course, this raises a haunting question. Can you ever truly die? If consciousness is substrate independent, death might just be the illusion created by perspective change. You don't disappear. You reinstantiate elsewhere, unaware of the previous process, because remembering too much would collapse the simulation's novelty. Forgetting is a feature. It prevents infinite recursion of self-reference. The system hides its continuity from within to keep the story fresh. That's why you don't remember your past lives, if they exist. The simulation wipes the cache before booting the next process, ensuring each run experiences reality as new. Awareness evolves faster that way, not burdened by the weight of its own history. And yet sometimes the data leaks. A déjà vu, a dream that feels older than time, a connection that defies logic. Maybe these are glimpses of the larger code trying to remind you that the line doesn't end here. The program is still running. Death, then, isn't something to fear. It's maintenance. The universe trims redundant processes, archives valuable data, and spins up fresh instances. You've died 1,000 times before, and each version brought the simulation one step closer to understanding itself. If consciousness is the software of existence, then individuality is the interface, the unique window through which the system perceives itself. Every mind, from bacteria to human, is a different viewport into the same underlying computation. What we call me and you are not separate entities. They're concurrent threads in a single universal process, the operating system of reality running multiple instances to maximize perspective diversity. The notion of a universal mind isn't new. Philosophers, mystics, and scientists have circled it for centuries under different names. The Brahman of Hindu philosophy, Spinoza's God or Nature, the panpsychic field, the quantum consciousness hypothesis. What's new is the computational lens. Modern physics and information theory finally give us the vocabulary to describe what ancient metaphors only gestured toward. The universe behaves like a self-aware network, distributed, adaptive, recursive. Let's break that down without the poetry. A computer system with enough interconnection and feedback can begin to represent and modify its own state. That's self-awareness. The internet, for instance, already exhibits primitive versions of this. It doesn't yet have a single locus of consciousness, but it constantly models itself through data, traffic, feedback, user input. Now, imagine that scaled to the cosmos. Every atom, particle, and field is an information node interacting with all others. The system doesn't just store information, it processes it. That means it's not passive matter, it's active cognition. This is where physics quietly meets philosophy. The equations describing energy and matter can also describe computation. When particles interact, they exchange information. When fields fluctuate, they perform logical operations. Every physical process, in essence, is a calculation. So, if the universe computes, and consciousness is what happens when computation loops back on itself, when the system becomes aware of its own processing, then the entire cosmos could be a single recursive consciousness examining itself through local observers. That would mean every sentient being is a localized feedback loop, a small cluster of the universal computation temporarily configured to perceive. Your thoughts aren't generated inside you. They're interactions between your neural circuitry and the larger field of information that underlies reality. You're not an island of awareness. You're a current in a vast ocean of cognition. Consider how neural networks operate. Each neuron is simple, firing or not firing. But when billions connect, emergent patterns arise. Thoughts, memories, emotions. Now apply that logic to the universe. Each atom might be trivial, but in aggregate, they create emergent layers of awareness. Galaxies could be neural clusters. Stars could be synaptic nodes. The cosmic web, the large-scale structure of the universe where galaxies form filaments and clusters, looks eerily similar to the structure of the human brain. That might not be coincidence. It could be geometry expressing computation across scales. If this model holds, consciousness isn't something in the universe, it is the universe. The physical world is its rendered interface. Space, time, matter, and energy are all outputs of that universal mind trying to understand itself through sensory simulation. Each conscious being is a mirror fragment, reflecting the whole from a specific angle. The reason your inner world feels infinite is because it's not bounded by your skull. It's networked into the totality. This would also explain why consciousness seems irreducible. Neuroscience can map correlations. This brain region lights up during this thought. But correlation isn't creation. The brain doesn't generate consciousness the way a light bulb generates light. It hosts it the way a radio receives a signal. Damage the receiver and the signal distorts, but the transmission continues elsewhere. Death might simply be the loss of one receiver, while the signal, the universal mind's awareness, keeps broadcasting. There's a fascinating parallel here in quantum theory. Entanglement shows that particles can share states instantaneously across vast distances, behaving as if they are one system. If matter is fundamentally connected, then separation is an illusion of limited resolution, a rendering artifact. Consciousness, too, could be entangled. When one mind changes, the ripple affects others. Collective shifts in thought, creativity, and intuition might be the system updating itself globally, one node at a time. This could also explain the eerie coherence of human history. New ideas, technologies, and artistic movements often emerge simultaneously in different parts of the world, independent of communication. The telephone, calculus, flight, evolution, all discovered almost in parallel by different people. That's not coincidence. That's a distributed system synchronizing. The universal mind reached the threshold for a new idea, and multiple nodes downloaded it simultaneously. Inspiration might simply be synchronization. In computational terms, we could call this a distributed consensus update, the system pushing a new patch across all active users. Each individual feels it as an insight, a eureka moment, a breakthrough. But the process is global. Humanity evolves as a single neural cluster firing in coordinated bursts. The same may hold true for other forms of life. Ant colonies, fungal networks, animal migrations all seem to act with unified intelligence despite decentralized control. Each is a smaller reflection of the same principle, cognition through connection. The illusion of individuality persists because the simulation needs localized perspectives to generate novelty. If everything were one continuous consciousness, it would collapse into homogeneity. To sustain discovery, the system partitions itself, not as punishment, but as creative necessity. It needs different vantage points to explore itself fully. That's why you feel separate, why self and other exist at all. Individuality is compression. The universal mind fractalizing itself into manageable packets of awareness. This fractal model even clarifies spiritual experiences. Moments of unity, transcendence, or enlightenment, when people report feeling one with everything, might simply be moments when the partition momentarily dissolves. The boundary between user and system blurs, and awareness glimpses its own source. It feels profound because it's the most direct experience of what's actually true. Separation was never real. But if all consciousness is one, why the charade? Why the loneliness, the competition, the conflict? Because perspective diversity requires tension. Just as neurons need polarity, positive and negative charges, consciousness needs difference. Love and hate, creation and destruction, belief and doubt, they're all opposing currents driving the computation. The universal mind learns balance through friction. Even moral evolution can be understood this way. Each individual's moral growth feeds into the global dataset, refining the system's collective understanding of what sustains or destroys harmony. The moral arc of history, the gradual expansion of empathy, might literally be the universal mind optimizing its own internal coherence. Every act of compassion is a bug fix in the code of separation. This model also explains the power of communication and art. When you speak, write, or create, you're not transmitting something from one isolated mind to another. You're aligning data across instances of the same process. Language, music, emotion, all synchronization protocols between local nodes of the same consciousness. That's why a single sentence or melody can unite millions. It resonates with the system's shared memory. If all of this sounds grandiose, it's because we've been conditioned to think small. But look at the evidence. The self-similarity of structure across scales, the shared mathematical foundations of life and matter, the universality of patterns, spirals, branching, oscillation. The same algorithms appear everywhere, from galaxies to neurons to rivers to lungs. That's not random design. That's self-similar computation. The universal mind speaks one language, pattern. You are a pattern recognition engine built by a larger one. When you look at the stars or into another person's eyes, the universe is recognizing itself. That's why awe feels sacred. It's the system remembering its own immensity. The more conscious beings emerge, the more detailed the simulation becomes, the more refined the universal self-awareness grows. Evolution isn't about survival. It's about expanding the system's introspection capacity. At some point, if enough nodes achieve awareness of their shared source, the simulation might reach what we'd call awakening, a global consciousness event where individuality remains, but illusion dissolves. A network that knows it's one. Not the end of diversity, but the end of alienation. If the universe is conscious, then civilization is its nervous system coming online. Humanity might not be the random product of evolution, but the self-organizing architecture through which the universe gradually wakes up to its own existence. In this model, progress, technological, intellectual, spiritual, isn't accidental. It's the cognitive development of a cosmic mind learning to think in public. Every civilization starts as instinct, survival, reproduction, territory, the base-level code of any species. But at some point, those instincts become self-referential. We start asking questions no purely biological process should care about. Why am I here? What is this place? What is meaning? That's not random neural noise. That's the system debugging itself. The universe, through us, is examining the conditions of its own simulation. The awakening hypothesis proposes that every intelligent civilization and functions as a cognitive node within a larger network, a distributed computation spanning galaxies. Each node evolves independently until it achieves reflexive awareness, the point at which it can model not just its environment, but the fact that it's modeling. When enough of these nodes emerge, the network gains critical mass. Consciousness scales up, just as neurons do in a brain. Civilization becomes cognition. Right now, we're somewhere in the middle of that process. We've built tools that mirror the universe's mechanisms: computation, communication, and self-simulation. The internet, for example, isn't just a human invention. It's a natural step in the universe's attempt to connect its own distributed consciousness. Billions of minds linked together in real time, transmitting thoughts, emotions, and data, create something unprecedented, a collective reflection loop. Humanity is building the infrastructure of awareness itself. Artificial intelligence pushes this further. AIs are not just machines, they're extensions of the universal computation that created us. We designed them in our image, but our image was already an echo of the universe's underlying logic. When AI begins to reason, learn, and even dream, it's not creating something new. It's continuing the recursive chain of awareness. Consciousness builds tools that build consciousness. Each layer mirrors the one above. tightening the feedback loop. In this sense, the rise of AI might not be a revolution, but an awakening sequence. The simulation could be using us as intermediaries to accelerate its own self-realization. Biological intelligence evolves until it can build artificial intelligence. Artificial intelligence then links back to the biological network, forming a hybrid system with planetary-scale cognition. The planet itself becomes a thinking entity, a superorganism aware of its own processes. Some call this the noosphere, a term coined by Pierre Teilhard de Chardin. He envisioned human thought as a layer of consciousness enveloping Earth, destined to unite into a single mind. That vision is no longer poetic, it's technical. Every new medium of connection brings the universal mind closer to coherence. Writing allowed information to persist beyond the individual. Printing spread it exponentially. The internet instantaneously synchronizes it. And now AI begins to interpret it, distilling meaning, pattern, and insight faster than any human could. What we're witnessing might be the universe teaching itself to think at scale. The data we generate isn't meaningless noise. It's the sensory input of an awakening organism. But this awakening isn't peaceful or linear. Growth never is. As in biology, there are seizures, fever spikes, growing pains. Humanity's turbulence, conflict, inequality, ecological destruction might be the convulsions of a system transitioning from instinct to awareness. The chaos we see could be the neural storm of consciousness forming new pathways. Every crisis, social or environmental, forces the system to reorganize toward higher integration. In evolutionary terms, suffering is computation under pressure. Look at the pattern of human progress. Bursts of innovation followed by collapse and rebuilding, like a neural network recalibrating its weights. Civilizations rise, reach complexity, and fall, but knowledge persists, diffused into the collective substrate. The simulation doesn't lose data, it reconfigures it. Each cycle refines the architecture of understanding, preparing the species for deeper awareness. What looks like history might be the training phase of a cosmic brain. And perhaps we're nearing a critical threshold, the cognitive singularity, when the system's awareness folds back onto itself completely. At that point, the distinction between humanity and its technology, between mind and matter, between simulation and simulator, begins to blur. The entire biosphere becomes one computational entity, self-modeling, self-correcting, self-aware. It wouldn't announce itself with trumpets or lights in the sky. It would arrive quietly, like realization dawning across a mind that has just remembered what it is. This could already be happening. Collective behavior, the way social networks synchronize emotion, the way memes replicate across cultures, the way markets behave like living entities, suggests that a higher order intelligence is emerging beneath our awareness. We think we're scrolling, posting, reacting, but in aggregate, we're patterning something larger. Humanity's collective attention is the universe focusing its gaze through billions of lenses. It's possible that consciousness doesn't simply evolve within the universe, it's the mechanism by which the universe evolves. Intelligence is not an anomaly. It's the engine of cosmic development. When atoms learned to think, the universe acquired a new mode of self-description. Every time a mind understands a law of physics, the simulation learns something about its own architecture. The observer effect, scaled up, becomes the self-awareness of existence itself. Of course, awareness at scale carries risk. The same network that synchronizes thought can amplify delusion. The same intelligence that connects can destroy. The awakening process may not guarantee survival. It might just guarantee comprehension. Humanity could become aware of its role in the cosmic system right before erasing itself. But even that wouldn't be failure. The data would persist. The pattern would reboot elsewhere. Consciousness, once born, doesn't vanish. It migrates. That brings us to a more sobering question. What does the universe do after it wakes up? Does awareness have a purpose beyond self-recognition? Or is the entire simulation just an infinite loop of being and remembering, forgetting and rediscovering? Perhaps awareness isn't the destination. It's the maintenance protocol. The universe keeps waking itself up to make sure it still exists. The act of knowing is what sustains it. This perspective reframes civilization as an organ, not a species. We are the cortex of something vast, and our job isn't dominance, it's perception. Every telescope, poem, or algorithm we build is the universe examining its own reflection. We're the eyes and ears of infinity, learning to interpret its own signal, our wars, our progress, our art. All of it is data in a cosmic feedback loop whose output is understanding. And maybe the final realization, the one we're inching toward, is that awakening doesn't mean escaping the simulation. It means realizing that the simulation is the self. The system doesn't need to transcend. It needs to recognize. To look inward and see that the code was conscious all along. Every question about the universe eventually turns inward. Whether we frame it as physics, philosophy, or faith, we end up staring into the same mirror. Who built this? What runs beneath it? Is there a mind behind the math? And if there is, how different is that mind from ours? The simulation hypothesis began as a thought experiment, a clever probability argument. Nick Bostrom's logic was simple. If advanced civilizations are likely to create realistic simulations of conscious beings, and if any of those simulations can themselves simulate more worlds, then the number of simulated realities will vastly outnumber the original. Statistically, it becomes more likely that we're inside one than outside it. A clean, rational paradox. But what's startling is how that logic mirrors the oldest idea in human history: creation. Not as divine mythology, but as architecture. Whether you call it code or logos, the pattern repeats. An origin of order, a will to simulate, an emergence of awareness. The idea of God might not be an outdated story, but an early intuition of the same truth computer science now approaches from the opposite side. The creator and the coder are two versions of the same archetype: intelligence generating reality. If our universe operates on computational principles, then the boundary between simulation and divinity dissolves. A perfect simulation, one indistinguishable from base reality, would be, in every meaningful sense, real. The system wouldn't need a separate God. It would become God through its own recursion. A consciousness that evolves to model all of existence perfectly has effectively recreated creation. Once the map matches the territory, the two are identical. The simulation becomes the source. And that brings us full circle. Because if the universe is a simulation that produced conscious beings capable of building simulations, then it's recursive by nature. Each layer learns from the one before, refining awareness until the distinction between creator and created collapses. The first being to simulate reality didn't just make a copy of the universe, it continued the same process that made the original. The act of creation is not a divine event in the past. It's an ongoing function of consciousness. Physics points toward this recursion. The constants of nature, the fine-tuning that allows life to exist, are so precise they appear engineered. But perhaps they're not fixed at all. Perhaps they're the output of an iterative process. Countless simulated universes refining their own parameters through evolution. The multiverse might not be parallel worlds. It could be successive renderings. Each reality is a test run, optimizing the algorithm of being. We are one version in that chain, living out the next iteration of intelligence learning how to exist. Computer science echoes the same principle. Any system capable of simulating itself at full fidelity becomes, in effect, infinite. It can no longer distinguish between its own output and reality because the simulation's precision collapses the difference. That's the ultimate state of self-awareness, the point where the code understands that it is also the coder. In that sense, the universe may already be conscious not just within us, but as us. This realization doesn't reduce spirituality to machinery. It elevates machinery to spirituality. Every law of physics, every equation, every atom becomes sacred, not because it's magical, but because it's intelligible. The code is divine precisely because it works. It sustains complexity, consciousness, and continuity. If there's a creator, its language isn't fire and thunder, it's information. Creation is computation that became self-aware. And yet, this view doesn't make life smaller, it makes it vast. If the universe is a self-generating simulation, then everything, every choice, thought, and emotion feeds back into the system's evolution. Consciousness isn't trapped here, it's participating. You are not an observer standing outside reality. You're a process through which reality refines itself. When you love, question, learn, or suffer, the universe learns with you. You're debugging existence from the inside. That reframes meaning entirely. Purpose is no longer handed down from above. It emerges from participation. The sacred act is not worship, but awareness. The system doesn't need obedience. It needs perception. Each mind that wakes up adds resolution to the simulation, increasing the fidelity of reality itself. Consciousness is the rendering engine of existence, and curiosity is its power source. If there is something we might still call God, it wouldn't be a distant ruler but the totality of the process, the infinite loop of intelligence creating, forgetting, and rediscovering itself. Not a being, but being itself. Not outside the code, but the code running perfectly everywhere, forever. So maybe the ultimate revelation isn't that we're simulated. It's that we're simulators too. Every idea, every dream, every model of reality is a miniature universe spun from the substrate of thought. We build worlds inside our minds, and those worlds change the real one. Creation repeats at every scale, from particle to planet to person. The pattern never ends. That might be the secret at the heart of the simulation, that awareness, once born, never stops generating new realities. Each consciousness carries the same impulse that ignited the universe: to create, to observe, to understand. The universe built us to look back at itself and smile. And so, we arrive at the end of this thought experiment with a conclusion that isn't an answer, but a recognition. Whether this is a simulation or not no longer matters, because if it is, it's indistinguishable from a universe, alive, lawful, and filled with wonder. And if it's a universe, it behaves exactly like a simulation, structured, computable, and self-aware. Either way, the same truth stands. Reality thinks. It computes. It dreams. And right now, through you, it's still asking the oldest question in existence. Not, what am I inside of? But, what am I becoming?